Hello cloud experts. So in this course we are going to talk about AWS which is Amazon Web Services. AWS is one of the leading cloud computing platform and ruling over the world. My name is Sanjay Kumar and I am a cloud trainer and consultant. So let's get started. Cloud computing is the biggest technology revolution around us, and this is changing the way how the IT infrastructure is being delivered, how services are being consumed. It is changing all the business models, whether old or new, and it is also defining how applications are being run and delivered and bringing in new opportunity for the businesses, whether small or big. And in this scenario, our data is stored somewhere in the cloud, which is like cloud-based services which are accessible from anywhere in the world. Now, why we need to learn AWS and who are the competitor to the AWS? AWS is one of the market leader for cloud computing, but the closest competitor what we have is Azure, Google Cloud and Alibaba. So let us understand where they stand in the cloud market. So if you look at this picture, the left side picture is called as Gartner Magic Quadrants. So in this case, the leaders quadrant have three companies, which is Amazon Web Services, Microsoft Azure, and Google Cloud. However, if you look at this, the right side of it, which is a report from Synergy Research Group, where AWS have 33% market share in the cloud market. When put together, the Amazon, Microsoft and Google have more than 50% market share of cloud computing. Now when we look at this, Amazon or AWS is the market leader for cloud computing from more than 10 years. Now, who should join this course? This course should be joined by everybody who want to start their AWS journey from scratch, who want to get a good overview of AWS services, who want to get started with using AWS services, and anybody who want to get started with AWS certification like AWS Cloud Practitioner or AWS Certified Solution Architect. However, a disclaimer here, this course may not be sufficient to clear exams like AWS Cloud Practitioner or AWS Certified Solution, but as of now, it is just a good way to get started with AWS. Any people in the mid-management level, sales professionals, or the people who want to know AWS at overview level, this course is a good starting point for them. Now, this is me, Sanjay Kumar, and I have around 18 plus years of experience in telecom, IT, and cloud industry. I have 12 plus years of experience in training and teaching. I have trained more than 10,000 students in 50 plus countries. I'm an AWS Certified Solution Architect and a cloud and AWS trainer and consultant. Now, the learning AWS is a big road ahead. However, we are just at the starting point. However, to reach to the destination or to become an expert in AWS, it is long way to go, but somewhere we have to get started. So let's get started and see you inside the course. Hello cloud experts. So before we start learning AWS, let us quickly understand what is cloud computing and why it is important for us to learn. My name is Sanjay Kumar and I am a cloud trainer and consultant. So we'll understand cloud computing, but before we talk about it, let us understand how the traditional IT infrastructure was developed in the corporate networks. So typically, all the physical infrastructure like servers, which includes processors, compute, storage, and networking components, they were actually deployed in the corporate network. On top of this, we had some platforms, which are typically the runtime environments, operating systems, and stuff like that. They were also managed within the corporate network, and all the services were deployed and provided by the servers which were available in the corporate network. All these resources can be connected by using the corporate network, and you have to be either available locally to configure these resources, or you have to connect through some VPNs, which will have a lot of limitation. However, now all these things, whether it is infrastructure or platforms or services, all these things can be stored in something called as cloud. We'll understand what is the cloud. But before we talk about it, this cloud infrastructure is available over internet. Anybody sitting anywhere in the world can access this cloud infrastructure and can do the configuration or commission some resources, or also release some resources as and when required. All these things can be done manually, and some of these functions can be done automatically as well. Now, to access these devices, you can do it from any mobile phone, any computer, or any laptops or desktop, etc. In addition to this, there are multiple tools available to configure these resources. You can do it with the web graphical user interface. You can do it with CLI commands, which is command line interface, or you can do it by using some APIs or SDK, which is like software development kits. So there are various ways to configure the cloud resources. Now, in simple words, what is cloud computing? Cloud computing is nothing but a remote computer or server which is remotely hosted. So if you really want to understand cloud computing in simple words, it is nothing but a simple computer or a server which is hosted in some other location which is remote from us, and that is why we call it cloud computing. However, if we really want to understand this in technical words, so it's a collection of large computing resources, large computing environments, which are typically called as data centers. Data centers are a shared pool of resources which can be provided to end user with an on-demand model. So in technical words, a cloud computing infrastructure is a large computing environments which are typically some data centers which are shared pool of resources which can be provided to the end user with an on-demand model. Now, what are the data centers? Data centers are the collection of huge computers or servers which will have almost infinite capacity. So we will have a lot of big servers available somewhere in the remote location, which are having all the power backups, all the redundancy, all the high availability, and they are available to be configured from internet, and any user can get these resources based on the requirement what they have, and they can release the resources whenever they don't want it, and they only pay for the resources what they use at a given point of time. Now, as per the NIST definition, NIST, which is National Institute of Standard and Technology, what is cloud computing? So cloud computing is a model of enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, which we discussed in the last slide, which is typically the data center, that includes network, servers, storage, applications and services, and that can be rapidly provisioned, so you can get it configured as and when you want, and you can also release it whenever you don't want it, with the minimal management effort from service provider interaction. So you don't really need to speak to the cloud provider to configure these resources or release these resources. You can do it whenever you want it, and you can release it whenever you don't really need it. So this typically cloud model is composed of three things. One is 5 essential characteristics, 3 different service models, and 4 different deployment models. We are going to talk about all these 3 things one by one. Now, before we talk about it, let us understand what are the other benefits of cloud computing. Cloud computing is changing the way how the IT infrastructure is supplied and consumed in the world, and all these things are now done virtually. On-prem data centers, the traditional data center, which is typically called as on-premises data centers, and now they have moved to virtually hosted environments with state-of-the-art features and services. So these hardwares, these softwares and the services are one of the best in the industry, and they are all virtually hosted and accessible via internet. Now, services can be subscribed as and when they require. So services can be subscribed on demand. You only pay for the services what you use. You only pay for the resources what you use. That's why they say pay as you go. Data centers are owned and operated by public cloud provider, the company like AWS, the company like Azure. These are the companies who are actually owning these data centers and also operating these data centers. Go global in minutes. Because these companies have global infrastructure available, you can launch your services, you can deploy your services globally typically in minutes. Time to market for services, because you can quickly deploy your services, your time to market for your services is extremely low. This cloud computing has become a game changer in the IT industry and getting very popular with the exponential growth. Now, just to take an example, there is one user who is looking for some server space which is like 16 vCPUs and 256 GB storage. There can be another user who needs some ready-made applications from the cloud computing, and there can be another user who just needs some additional storage for his application. Now, cloud computing provides all these various type of services, whether it is related to only to the storage or related to the applications or some kind of compute capacity. Now, what are the different characteristics of cloud? The characteristics of cloud, the first one is on-demand self-service. That means the end users can access these resources, can configure these resources by using self-service portals, and can create it whenever there is a demand. Now, broad network access, that means these resources can be accessed from anywhere in the world by variety of equipment and variety of tools. Multi-tenancy and resource pooling. We have talked about resource pooling already, where all the resources, all the data centers are pooled in, and they are given for the multi-tenant architecture, where multiple users are actually sharing the same infrastructure. The capacities, the compute capacity or the storage capacity can be increased at any point of time. So it comes with rapid elasticity and scalability, and they normally come with some automatic tools where they can increase the capacities as and when they're required by setting up some thresholds, and whenever those thresholds are met, they are actually increasing the capacity, and whenever these values are going down, they can also decrease the capacity. Now, major services, all the services what we use are being measured in the real time, and you only pay for the services what you use. Now, cloud comes with three service models. The first one is called as IaaS, which is called as infrastructure as a service, where you are just using the infrastructure part of it. The infrastructure means here the virtual CPUs, the memory, storage or networking resources. So you move your platform and applications to the infrastructure which is available in the cloud. However, it comes with another service model called as PaaS, which is called as platform as a service. In this case, you also get the infrastructure, but along with the infrastructure, you also get app development tools, runtime environments, some integrations, OS images, all those things, and you build your applications by using these platforms and the underlying infrastructure. However, if you really want to use the services directly, you have another service model called as software as a service, where you can use application related to notification, queuing, SMS, emails or workflow, and you can use these services directly. Now, to understand this, let us have a look at this picture. So in case of traditional IT, all these functions from here to here, whether it is applications, data, runtime environments, middleware, OS, virtualization, servers, storage, networking, all these were the responsibility of the customer. However, in the case of infrastructure as a service, customer is responsible for the applications and the platform, and the infrastructure part is now taken care by the cloud provider. In case of platform as a service, the customer takes care of only application and data part of it, and all other part related to the platform as well as the infrastructure is taken care by the cloud provider. However, in case of software as a service, all the things from the physical infrastructure till the applications are the responsibility of the cloud provider, and consumer, the end user, is just going to use these services and paying for the services what they use. Now, cloud also have 4 deployment models, which are called as public cloud, private cloud, hybrid cloud and community cloud. The public cloud is the cloud infrastructure which is available for anybody and everybody. Anybody can subscribe to these resources and can use these resources whenever they are needed. In case of private cloud, this is a cloud infrastructure which is actually built for one particular organization and it is used only within that organization. In hybrid cloud, you use a mix of private and public cloud where you have your on-prem data centers. However, what you want to do is some additional capacities or additional storage, and those things can be consumed over public internet, so public cloud. Right. So in this case, hybrid cloud is a kind of you have on-prem data centers or some private cloud as well. At the same time, for additional capacities or workloads, you are also relying on public infrastructure. The community cloud is typically designed for some community welfare related to health, social or government related stuff, and this is typically available for a certain community or special help groups. Now, just to understand private cloud, the end-to-end infrastructure is managed by one particular organization and it is only used for one particular organization. In hybrid cloud, you are using a mix of private cloud and the public cloud. And in the public cloud, you are using the resources from company like AWS or Azure, and these are the typical cloud which are being used as a public cloud. So these resources can be used by anybody and everybody, and they can consume these services. They can actually deploy these services by using internet access to these cloud computing and can set up all their resources according to their requirement. Now, what are the typical application today? Day in and day out, whatever applications we are using, most of those applications are actually built on cloud computing. Some of these applications can be Zoom, can be Google Classroom, which is used for online classes for the kids, Google Drive, which we are typically using for the storage, and WhatsApp, YouTube, or Google Meet. So these are some of the applications which we are using on daily basis, and all these services are actually built on the cloud computing platforms. Now, who are the leading cloud service providers? So AWS is one of the market leader for cloud computing services, but followed by another three companies, which is like Microsoft Azure, Google Cloud, and Alibaba Cloud. However, these three companies, AWS, Azure, and Google, have acquired more than 50% market share in the cloud computing market. Now, if you look at this picture, this is a Gartner Magic Quadrant, where we see the leader part of it. And in leader, the AWS or Amazon Web Services is the market leader for more than 10 years, followed by Microsoft and Google. Now, if you look at the right side of it, which is market share in the Q2 of 2020, and this is a report published by Synergy Research Group, where we see Amazon has a market share of 33% and Microsoft has a market share of 18%, and Amazon have a market share of almost twice of Microsoft. So AWS is actually have market share almost twice of the closest competitor. Now, that's all what we have in this session. I hope you enjoyed the session. Look forward to see you in the next session. Hello cloud experts. So let's get started with the AWS introduction and history of AWS as well as the global infrastructure of AWS. My name is Sanjay Kumar and I am a cloud trainer and consultant. Now let's talk about the brief history of AWS. The AWS was internally launched in Amazon in 2002-2003. However, the first service which was launched is called as SQS or Simple Queuing Service in 2004. In 2006, they officially launched AWS with services like SQS, S3 and EC2. SQS is called as Simple Queuing Service, S3 is called as Simple Storage Service, and EC2 is Elastic Compute Cloud. So we'll talk about all these services in some future sessions. In 2007, they launched in Europe and they had 180,000 developers on their platform. In 2010, whole Amazon.com moved over to AWS. In 2012, they launched first reInvent, which is the largest tech event on the planet. And today they have more than 6,000 functions and services, and AWS is the global leader in the cloud computing market. Now let's have a look at the AWS global infrastructure. This picture is taken from aws.amazon.com, and if you really need to know more about it, you can simply visit infrastructure.aws. So now when we look at this, it has got 24 different regions which are launched, 77 availability zones, 216 point of presence where we have 205 edge locations and 11 edge caches. And they have covered 245 countries and territories, and these numbers keeps on changing. So it is good that you are not being tested for these numbers in the AWS certification exams. Now, what are AWS regions? AWS region is a geographic location which consists 2 or more AGs, which are typically called as availability zones. Some regions can have 2 AGs and some regions can have up to 6 availability zones. So a region is a geographic location which can have 2 or more availability zones depending on the region. A region is a group of multiple data centers, and these availability zones are typically these regions are typically named as EU East 1, EU West 2, etc. And most of the services which are available in AWS are region-based services. However, there are some services which are global services, but mostly services are actually region-based services. Now, what are the availability zones? Availability zones are different cluster of data centers within the AWS region. So each region may have 2 or more availability zones, and all these availability zones are connected to each other by using high bandwidth and low latency links. Each availability zone can have 1 or more data centers, and these availability zones are geographically separated from each other with redundant power supplies, redundant networking mechanism, and different kind of connectivity. They are also created in different floodplains and different earthquake zones as well. Now, what are typically data centers? Data centers are a collection of huge computers or servers which will have almost infinite capacity. So basically, these data centers are the big racks of servers, and all these resources are pooled in, which is typically called as shared pool of resources. And all these resources can support multi-tenancy kind of architecture, and n number of different users, small or big corporates, can access these resources and can configure these resources by using internet from anywhere in the world. Now, this may be a picture with this is how the AWS data centers typically looks like. So these are the sites where you have AWS data centers available. AWS point of presence, which is typically called as edge location, and these edge locations are closer to the end user and more in number than regions or availability zones. These are typically required to enhance the consumer experience, and these are typically called as content delivery networks, or we call it as CDNs. CDNs, services of AWS, is called as CloudFront. So CloudFront is the name of the services which is used as CDN in AWS. It can be used for both read and write. We will understand in the further sessions what do we mean by both read and write. Typically, when we talk about edge locations or content delivery networks, what we understand is that they are only used for reading, but in some of the services, these edge locations can be used for writing into it as well. Now, AWS have 216 point of presence, which includes 205 edge locations and 11 edge caches. AWS pace of innovation, again this picture is taken from aws.amazon.com. They have more than 6,000 different services and functions available, and they are actually growing these numbers very quickly, and every time you log into your AWS account, you will see one or the other new services which are available. So they have the great pace of innovation. They have a lot of services available, and these services are being actually growing day by day, and also they are enhancing the consumer experience as well as the network experiences. Now, AWS have something called as which is shared responsibility model. What is shared responsibility? There are two things here. The responsibility of security of the cloud. The security of the cloud is the responsibility of the AWS, and security in the cloud is the responsibility of the customer. So typically what they call it, the shared responsibility model. What do we mean by shared responsibility model? That means security of the cloud is the responsibility of AWS, and the security in the cloud is the responsibility of customer. Now let us understand all the regions, availability zones, edge location, hardware and global infrastructure, compute, storage, databases, networking, and the software available in that. They are all the responsibility of AWS. However, all the things related to the operating systems, network, firewall configuration, platform applications, identity and access management, and the customer data is the responsibility of the end customer. Now typically, how do we look at this? All the things which is related to the infrastructure is the responsibility of AWS. Anything related to the platform and the services is the responsibility of the customer. However, these things will also vary depending on what services are being used and in what kind of service model you are. So if you are in IaaS or PaaS or SaaS, some of these responsibility metrics will change. But this is typically called as AWS shared responsibility model. Now, let us quickly talk about what are the different AWS certification we have. So AWS have various certification available. Some of these things are at foundational level, which is typically called as AWS Certified Cloud Practitioner. Then we have some certificates available at the associate level. So we have AWS Certified Solution Architect in the architect level, and SysOps Administrator and AWS Developer. So these three are associate level certification, and then there are two professional level certification, which is AWS Solution Architect Professional and DevOps Engineer Professional. However, they also have some specialty certification related to advanced networking, security, machine learning, Alexa skill builder, data analytics, as well as databases. They keep on adding these different certification. So every time when you see, you may find couple of different certification than what is shown in this picture. So that's all for in this session. Look forward to see you in the next session. Cloud experts. So let's quickly have a look at the AWS console and AWS free tier. AWS allows you to use its resources for free, but there are some limitations which you should always be sure about it. My name is Sanjay Kumar and I am a cloud trainer and consultant. Now, AWS free tier. AWS, as I mentioned, gives you a free tier account where you can use some services. However, some of these services are always free. Some of these services are 12 months free, which is typically starts from your sign up date, and there are some trials which is actually starts from the date when you activate a particular service. Now, if you really need to know more about it, simply log into aws.amazon.com/free. It will give you all the details which are available in the free tier. Just to give an example, so it gives you Amazon EC2. If you're not sure what is EC2, don't worry, we're going to talk about it in the next few sessions. So Amazon EC2, they give you every month 720 hours of EC2. However, you have to be very sure which particular instance you're using, because this 750 hours available on only one particular type of instance. So whenever you create these resources, you have to be very sure what kind of resources are being created, and sometimes you may have some additional charges for that. S3, which is simple storage service, it gives you a storage of 5 GB, which is free for 12 months. So here you will see some other information is also mentioned. These services are available for 12 months, and these services are available always as free. Amazon SageMaker, which is typically used as a free trial, and Compute, which is AWS Lambda, which is always free. Now Amazon RDS, which is typically relational database services from Amazon AWS, which is again free for 750 hours. Amazon DynamoDB, which is non-relational database, and AWS Lambda, which is typically called as machine learning. Now if you look at this, here also see, here you can click something called as feature or 12 months free, so you can align your services according to your need or which is available as trial. And you can also align these services based on the categories what you have. So you always need to check the AWS free tier in detail before you actually start using, otherwise it may incur some charges to your account. Now whenever you want to create an AWS account, you simply go to aws.amazon.com and create a free account, which gives you 12 months of free tier access. The free tier access we have just discussed in the last slide, where you have to put an email address, which is typically be your AWS the root account. This email will be this email address will be connected to your AWS root account, and you need to put your password, and you need to confirm your password and need to define a name for your AWS account. So once you do that, it will ask for some other details, whether you want to create it as a professional or personal. As we are creating it only for the personal purpose, it simply gives we will simply select the personal part of it, and then we will write our full name, phone number, country of origin, some addresses, and we also need to connect our credit card to it. It typically takes 2 rupees or some small amount depending on your country from your credit card, and it refunds back that amount to your credit card. Now when we are done with our sign up, we can always log in by using either root user. Root user is the user which will always have the highest permission, and you should not use your root user account very frequently. So for a normal workloads and normal work, you should always use something called as IAM user. IAM is called as Identity and Access Management. We are going to talk about that as well. So IAM user, under one root user, I can have multiple IAM users, and I can also assign what are the authorizations those IAM users will have, what are their capabilities, what they will be allowed to do with the AWS resources, whether they will be able to use some services or not, whether they will be able to create some new resources or not. So each and everything can be assigned to these IAM users. We are going to talk about these IAM users in detail. If you are accessing by using root user, you will be using root user email address and the password. Please don't forget to set up something called as MFA. MFA is typically called as multi-factor authentication, and you can do it by using some hardware devices or some virtual MFA devices. Now once you log in, you see a window similar to this, and typically this window keeps on changing from time to time, so it may be slightly different when you log in. But here you will see the name of your AWS account, and this is the place where you will see the region, in which region you are, and the support for this AWS account. Here we have something called services. You can find the services by clicking this particular button, or you can search for some services like EC2 by typing here as well, and it also shows you some of the services which are recently visited. Now when we click on the region part of it, when we click on this, what we see here is multiple regions. So we have US East 1, US East 2, US West 1, US West 2, in Africa, in APAC, in Canada, in Europe. So these are the various regions which are available in AWS Global Infrastructure, and under every region we can have multiple AGs, which are typically called as availability zones. Now when we click on the services tab here, on the services tab, what we see here is the list of services, and all these services either I can categorize under a group. So all the compute services are categorized under compute, all the analytics services, they are grouped under the analytics group, or we can also look at these services based on the A to Z. So you can actually align based on the A to Z or based on the group. So let us understand a little more about account. So when you click on my name, I see my account, my organization, my service quotas, my billing dashboards, the orders and the invoices, and something related to my security credentials. And by using this button, you can sign out from your AWS account. Now, what are the different service categories available? So, AWS have various service categories related to the analytics, application integration, AR/VR, augmented reality and virtual reality, AWS Cost Management, blockchain, databases, customer engagement, containers, compute, business applications, developer tools, end user computing, game tech, Internet of Things, machine learning, management and governance, media services, migration and transfer, mobile applications, networking and content delivery, quantum technologies, robotics, satellite, security, identity and compliance, and storage. These are the various service categories which are available in AWS, and under every service category they have multiple services available. And this picture is taken from aws.amazon.com, and if you need more details, you can simply visit aws.amazon.com. Now that's all in this session, and look forward to see you in the next session. So in this session we are going to talk about AWS free tier and how to sign up for a new account. So in this scenario, what we are going to do is we are going to talk about aws.amazon.com. We will just type in the browser aws.amazon.com/free. So when this page opens, what we see here is AWS free tier account, and it tells you there are services which are always free, some services which are 12 months free, and then some are the trial services. In the left, you can also see you can choose your services based on the tiers, which services are the featured ones, 12 months free, always free, and trials. You can also have a look at the product categories, which are like analytics, application integration, AR/VR, and some other categories for products and services from AWS. In the right side, you see various services which are available for free. So for example, the compute services, the Amazon EC2, 750 hours, which is free for 12 months. At the same time, Amazon S3, which is 5 GB again, and 12 months free. Amazon RDS, again 750 hours for 12 months. So these values, 750 hours, are per month kind of limitation. If you look at Amazon DynamoDB, which is 25 GB of storage, is always free. Amazon SageMaker is available as a free trial for 250 hours. AWS Lambda is always free with 1 million free requests per month. So like that, you can have each and every service and the details in the free trial. However, when you look at this, there are a lot of different pages available, and you can see Amazon CloudWatch, Amazon API Gateway, and n number of other services. So you can scroll it to different pages and you can understand what are the services which are available. But one thing you have to be very sure, when you talk about Amazon EC2 and it says 750 hours, you have to be very sure which particular instance type you are going to use. Now, for example, if you look at the fine print of this, the only instance which will be free, for free tier is either going to be T2 micro or T3 micro, dependent on which region you are in. So you can't really use other instance type. You can only use either T2 micro, T3 micro, depending on the region where you are in. So you have to be very sure which instance you are choosing. We will also see how to limit our usage to the trial version only or the free tier only. So we'll see how we can avoid spending any money on AWS account. So if you really want to create a free account, you simply need to click on create a free account here. And you have to use your email address and the password. And confirm password and set up a name for your AWS account, and simply you have to click on continue. Now, if you really already have a AWS account, so this account when you create, it will ask for the credit card details and all, and they will deduct some small amount from your account and will refund it back once it is done. That is just for the verification of your credit card. Now, if you already have AWS account, you can simply click on this link here and open a new page which will allow you to connect to your existing AWS account. So let's move forward and click sign in our existing AWS account. So while signing in, it gives you two options. Either you want to log in into as a root user, or you want to log in into as a IAM user. So root user is the user which will have highest permissions and will have all unrestricted access to all the resources of AWS infrastructure. However, within an organization, I can have multiple IAM users, and those IAM users will have different type of permissions on what they can do with the AWS infrastructure. So for root user, you have to use your email address. You have to use your email address which you have used for logging into AWS account, and then move forward. And for IAM users, you will need some account ID or account alias for your account, and after that you will be able to give your username and password. So let's move forward and try logging in by using our root user. So here we are in our AWS root account. So in this case, if you see here, it will be shown as your account name. If you click on this, you're going to see multiple options, which is my account, my organization, my service quotas, my billing dashboard, my security credentials, and sign out options. If I click on the next bar, here I will see the list of regions what I have. So by default, I'm logging into the Mumbai region, but if I want, I can also move to Northern Virginia or any other region for that matter. It also depends on how I really want to deploy my workloads, and also where are my users. So I always wanted to have my regions closer to my end user who are going to access these resources day in and day out. However, it depends on a number of other factors as well. The pricing for various resources are going to be different from region to region. If you really want some support, you can always go to support center or some expert help, or you can get into the forums, documentation, training, and some other resource centers as well. If you want to look at the services, here in the left side you have the services tab, and when you click on this, you will see all the services which are available in this particular in this particular region. And in the left side, it will show you all the services which are recently visited. And when I click on this, I can do this. I can search for any particular service, for example EC2, and it will show you all the EC2 services and all the related services where EC2 is being mentioned. Or if I really want to do it, I can simply close this and click on the find services from here. So I can simply find these services from find services tab. You can check all these things on your AWS console mobile app as well, and it also gives you some other options depending on which regions you are in. If I want to change the region here, I will simply go to the regions list and simply move to Northern Virginia. Please note, some of the services may be different or may not be available in one region and may be different from one region to another region, and the pricing is also going to be slightly different from one region to another region. That's all about this demo. Let's move forward with the next session.
Hello cloud experts. So in this session, we are going to talk about AWS service categories and some of the AWS services what we are going to cover in this particular course. My name is Sanjay Kumar and I am a cloud trainer and consultant. Now, what are the different whenever we in the last session we have talked about how you can log in into AWS console, and once you log in into AWS console, when you click on services, you see various service categories like compute, storage, security, identity and compliance, IoT, end user computing, business applications, analytics, and so on. You can categorize these services under groups, or you can simply list them from A to Z. And it also shows you the recent services what you have used in your AWS account. Now, what are the different, these are the various service categories we have. However, we are not going to talk about all these AWS services in this course, and typically it is not possible for anybody to know or become an expert in all these services. So what are the services we are going to discuss in this particular course is compute, So we'll talk about some of the compute services. We are also going to talk about some of the storage services. We are going to talk about AWS security, identity and compliance services. We are going to talk about some of the database services as well as some networking and content delivery services. So these are the 5 different categories what we are going to cover in this particular course. Now, service of covered in the course, we are going to talk about compute, storage, databases, security, identity and compliance, and networking and content delivery. So let us understand what are the different services in these categories, and out of that, what are the major services we are going to use. Now, when I talk about security, identity and compliance, the first one is IAM, Identity and Access Management, Guard Duty, Inspector, and WAF and Shield, where WAF is known as Web Application Firewall. And in this particular section, we are going to talk about only IAM as a service. We are not going to talk about all these services in detail, but yes, we will briefly talk about those other services. In case of compute, we have EC2, which is Elastic Compute Cloud, Elastic Beanstalk, Lambda, and Lightsail. However, in this section, we are going to talk about only EC2 service. We are not going to talk about all these other services in detail. In case of storage, we have S3, which is Simple Storage Service, EBS, Elastic Block Storage, EFS, which is Elastic File Storage, and S3 Glacier. However, what we are going to discuss mainly here is S3, which is Simple Storage Services, and briefly, we are also going to talk about S3 Glacier, which is typically a file archive system. Now, in case of databases, we have RDS, which is the Relational Database Services, DynamoDB, which is Non-Relational Database Services, Redshift, which is Data Warehouse, and Elasticache, which is typically the caching services. However, in this, we are going to talk about RDS, Relational Database Services. Services, in case of networking and content delivery, we have VPC, which is Virtual Private Cloud, Route53, which is typically the DNS service, CloudFront, which is typically, so Route53 is the DNS service of AWS, CloudFront is the CDN service of AWS, which is also called as Content Delivery Network, and Direct Connect, which connects the remote data centers to the AWS cloud. However, in this case, we are going to talk about VPC service, which is Virtual Private Cloud, and Route53 services. So these are the services which we are going to discuss in this particular course. That's all in this section. Look forward to see you in the next session.
Hello, cloud experts. Security is one of the biggest concerns in public cloud infrastructure. And now we are going to talk about one of the services related to the security domain, and that service is called as IAM, which is Identity and Access Management. My name is Sanjay Kumar and I'm a cloud trainer and consultant. Now let us understand what is IAM. IAM is used to identify and access management, allows us to manage the users and how they can access the AWS resources by assigning something called as policies. Now, what is IAM? IAM is required to create various users, groups, roles, and something called as policies. And these policies are assigned to users, groups, as well as the roles, so that they can work with your AWS resources. So they can create AWS resources and manage AWS resources based on the policies assigned to them. Now, understanding IAM is very important both for the certification as well as managing real-life AWS accounts. So it is from the both perspective, it is very important because we will get a lot of questions related to IAM in the certification as well as managing your real-time AWS infrastructure. IAM is equally important. IAM allows us to create many users in a single account and control their access to the AWS resources. So we can create many users and we can also control what actually they are able to do with the AWS infrastructure. Now, what are the various features of your IAM? So IAM offers centralized control of your AWS account. So we have single AWS account, but we will have various users and permissions so that they can do limited things with our AWS account. So we have a centralized control over our AWS account. Shared access, the access to the resources is shared between number of users. Granular permissions, the permissions can be fine granular so that they can do what they're supposed to do by using those username and passwords. Identity federation, so you can use Active Directory, Facebook, LinkedIn, and you can use identity federation by using some of these tools. It also allows you to have MFA. MFA is called as multi-factor authentication. By using that, you can have authentication with multiple factors. So one factor of your authentication can be your username and password, but other than this, we can also have some hardware and software MFA tools which can be used for authenticate you further. It also integrates with many other AWS services. It also has something called as password rotation policies, and this IAM feature is PCI DSS compliant. So whenever we are having a credit card and debit card, so for that there are some standards called as PCI DSS, and IAM is also compliant with that. What are the key terminologies we have in the IAM? Called as users, groups, policies, and roles. So let us understand what are these different terminologies what we have in the IAM. So let's talk about users. Users are typically individuals or employee of an organization, and they are typically called as users who can have access to the AWS resources. However, a number of users who requires similar capabilities, we group them together by using something called groups, and all the users of similar authority can be grouped together, and we will assign this policy to the group itself instead of giving this policy to the end user. And all the users will have the group permissions. So whatever permissions are given to the group, those permissions will be there with the user as well. The third one is called the roles. Roles are created whenever some AWS resources accessing other AWS resources. So these kind of things are required. The roles are typically required when we have some users who want to access some AWS resources, want to access some other AWS resources. For example, some of the compute services, they want to access some resources on storage. So we need to give them a role which will allow them to access S3, which is typically the storage service. However, users, groups, and roles by default have absolutely no authorities. So to give them some access to the resources, we also need to create something called as policy, and these policies are typically some JSON documents which are assigned to either users or groups or roles. However, so we can have multiple policies given to the users, groups, and roles, and all those policies are typically the JSON documents, and which will define what are the permissions you have to access those resources. Let's move forward. So let us understand what are the different type of users. We have one user which is called as root user. Root user is the one which is created by default whenever you create your AWS account, and it carries highest permissions, and this should not be shared with anybody. So root user should not be shared with anybody, and it is created by default whenever you actually create your AWS account, and this carries some of the highest permission related to your AWS infrastructure. Users are individuals from your organization which can be given different level of permissions. So different users in an organization, they are supposed to do various different things with the AWS infrastructure, and they should be given the permissions to do those things at the different levels. Groups are typically a group of users which requires the similar or same permissions. However, what we can do is we can have multiple users in the same group, but one user can be a part of multiple groups as well. And in addition to this, we can have user is having some additional policies more than which is available for all other users in the group. So we can assign separate policies to individual users in one particular group. However, it is not mandatory for users to become a part of a group. and one user can become member of multiple groups. So both things are true. It is not mandatory for one particular user to become a member of a group. I can have individual policy for a particular user. At the same time, one user can become member of multiple groups as well. Now, what is IAM policy? IAM policy, this is typically a JSON document, so which is written here in the JSON. So if we see statement, it says effect, allow, action, S3, and resources, start. What it says? That means this particular policy defines some allow attributes to a user on which particular service? S3 service, which is typically called as simple storage service, and this is applicable to all the resources in the S3. So this user will be able to create buckets. We have something called as buckets, which we'll discuss further. So it will be able to create access buckets. It will be able to look at the objects, delete the objects, create the objects, upload the objects. So it will be able to do everything, each and everything in the S3 services. However, if I give this policy to somebody, he will not be able to access the resources in EC2. So he will not be able to do that, the create a EC2 instance. If you are not sure about what is S3 and what is EC2, don't worry. We are going to talk about all these things one by one. Now, IAM policies, they are typically assigned to users, groups, as well as roles, depending on what are their access levels. One user, group, and role can have multiple policies. So it is not mandatory to have all the permissions in one policy. You can have different permissions in different policies, and you can assign more than one policy to one particular user, group, or role. These policies are typically JSON documents, JavaScript object notation documents. Always follow the least permission principle and do not give permission more than what they should do. So by default, users, groups, and roles are not allowed to do anything. So by default, they have absolutely no permissions and they are not able to access any resources in the AWS infrastructure. However, whenever we are giving them permissions, we should make sure, we should understand what they are actually they have to do with the AWS infrastructure, and we should always go ahead with the least permission principle. We should always give them the minimum permissions to use AWS resources depending on their job roles. By default, there are no permissions given to users, groups, and roles. So by default, they have absolutely no permissions, and all these permissions are actually given by the policy documents. IAM roles. The roles are required when AWS resources are trying to access other AWS resources. For example, one EC2 instance want to write some files in S3, which is simple storage service, then EC2 will be assigned with a role which will give them access to the S3 with a policy of S3 access. So in this scenario, we will create a policy called as S3 access, and that S3 access policy will be created using a role. A role will be created, and that role will be given this policy, which is S3 access, and EC2 will be assigned with that particular role. So in this case, EC2, which is typically like a virtual machine, will access the S3 resources by using a policy which is S3 access. So Amazon EC2 will have a role, and in that role there will be a policy, and by using that policy it will be able to read and write files in simple storage service, which is typically called as Amazon S3. Now, how to use AWS resources? There are various ways to use AWS resources. You can do it by using AWS console, which is typically a graphical user interface. CLI, command line interface, which requires something called as access key that we will see in the next session. What is access key and how these access keys are being used. We will have some API and SDK, which is software development kit, APIs and SDKs, and they can also access the resources by using access keys. So this is how typical access key looks like. So they have something called as access key ID, and you need to have that secret access key and the secret access key, which is not shown here. So these things will be used for programmatic access, which is typically used for CLI or API and SDKs. Please make sure you don't share your access key ID and the secret access key with anybody who you are not very sure how they are going to use these things. Multi-factor authentication, somebody getting access to the username and password can access your AWS resources. So sometimes it can be dangerous if somebody steals your username and password and they can do whatever they want in the AWS resources. To avoid this, what we do is we just add one extra layer of login security and we enable MFA, which can be done based on some hardware MFA devices called as, for example, this is Gemalto, and we can also do it by virtual MFA devices, that is Google Authenticator. There are multiple apps and multiple devices which are available to do MFA. However, just to take an example, we have used Gemalto and Google Authenticator. So you simply need to install this application in a mobile phone, and absolutely no issues. If you lose your phone, you can easily by using different mechanism, you can easily break this MFA alignment with your AWS account, and you can also do it by using the AWS support. So it gives you extra layer of security. So without using this Google Authenticator app, nobody will be able to access in your AWS account. Now the username, so extra layer of security, username and password, and after that what you have is some MFA device, and in this case I have taken example of an app called as Google Authenticator. So we can use Google Authenticator app to make our AWS account secure. That's all in this session. So in the next session, we will have some hands-on practice on IAM, and we will discuss all these things what we have discussed in this session. So thanks for watching this session and look forward to see you in the next session. Hello cloud experts. So let's get started with a quick demo of IAM. So either you can open IAM by using these recently visited services. So you'll see all the recently visited services here, or you can simply type in here IAM. You can click on this link and get into IAM, or you can go to the services tab here, and that services tab you will see security, identity and compliance. Under that you will see a service called as IAM. You can click here on IAM and IAM page will open. And if you look at this in the upper right part, so I'm just increasing the size a bit. Okay, so in the upper right part you will see global. That means IAM is a global service and your username and passwords are available across all AWS regions. So here in the left side you will see the dashboard. In the dashboard you will see groups, users, roles and policies. So we are going to talk about all these four things one by one. There are many more things, but as of now we are going to talk about all these four things: groups, users, roles and policies. So let's get started with users. So in case of users, I will simply click on users here. These are going to be IAM users. So IAM user means they are going to be identity and access management users. They will be created under root users, and I can define what permissions they will have to access AWS resources. So let's move forward by starting with add user. So when I click on add user, so I will see CTG1, which is Cloud Training Guru 1. I can create multiple users at the same time, but as of now I'm going with only one particular user. Now there are two different options available. Either I want to go with access types, whether which is like programmatic access, which allows me to log in into AWS infrastructure by using a access key or secret access key, which is required for AWS APIs, command line interface or SDKs and some other development tools. So if I really want AWS API, CLI or SDKs and other development tools to log in into my AWS account, I will give them programmatic access. However, if I want the end user as human beings to log in into these AWS infrastructure, I will go with AWS Management Console access. So this is what I'm going to choose. I'm going to create either it can be auto-generated password, or I can go with a custom password. So in this scenario, I'm going with a custom password, and there are some limitation on custom password, which I have chosen as CTG12345. That means it has to be minimum six alphanumerical letters. So I will go with custom password here. And whenever the user is logging on for the very first time, do I want that user to reset the password? If I want to do it, I will select it, otherwise I will uncheck it. Now the next permission, we'll move next towards permissions. Either I can assign some policies here. So add users to the group. I can add users to the group, or copy permissions from existing user, or I can attach existing policies available directly. Now, what I want these users to do, either it can be a user which is the administrator access, or I want users which can write some S3 buckets. So I can go with Amazon S3 full access, or I want some users who can create some EC2 instances, and I can go with EC2 full access. So depending on what these users are supposed to do, according to that, I will give them different permissions. And these permissions are given by something called as policies. We will talk about policy a little later. So as of now, I'm just giving one policy of administrator access to this particular user, and we will see what do we really mean by it. Next, I can add some tags. I can say this person is from a department, and department is development. So this is the key department and the value as development. So I can create some tags, so it helps me to keep a track of my all AWS resources. Next, review. I will simply review it. So username, AWS access type with a password, console password type, required password reset, and permission boundaries. So whenever I go with this, I can actually create a user like this. So I will simply go ahead and create a user here. Now my user is created, and if I really want to download this file, so I can download the details of this particular user. At the same time, if I have chosen programmatic access, in that scenario, I can also go with I will also get some access key and secure access key. However, these users will not be able to log in by using aws.amazon.com. Instead of that, they will going to use this particular URL which is mentioned here. So I will simply copy this URL and open a incognito window, and when I open this, I will simply type the same stuff here. Now, if you see this, either it shows me the account ID 12 digit or account alias. So account alias is mentioned here. My username was CTG1 and my username was CTG12345. So I'm just going ahead with that. Sign in. So this is now my IAM user which is available. So my IAM username is CTG1 and my account name remains the same. So we can sign out and go back to our root account. So we are here back in our root account. By using this, we have just created a user. Now let's go back and start creating a group. Now in this case, we are just creating a group, and that group name is development group. So I have created a group for developers and department is development department. So I'll go ahead, and now what I can do is, what is the policies which should be given to the users, or I'll say the groups. So all the users, I can have many users in the same group, and the policy which is given to the group is available for all the users in this particular group. So in this case, let's say I have already given admin policy to the user, so it doesn't matter what policy I give here. But if, let's say, just to take an example, I am giving S3 full access to this particular group, so every user who is a part of this group will always have full access to the S3 service, but they will not be able to do the other, they will not be able to use other services. So next, add step. So now we are just creating the group here. As of now, we have just created the group. Now click on this group action, add users to the group. So now, as of now, we don't have any users in the group, so we can simply click on this particular user and add this user to the group. So user one is now part of the group which is development. If you really want it, I can simply click it here, and I can remove users from the group as well. Now let's move forward and just understand what are the roles. The roles are similar to the user creation, but they are actually not designed for the end users or the human beings. They are actually designed for services which wants to access other services. So let's say I want to create a particular role, and I want to create this role where EC2 allows EC2 instance to call AWS services on your behalf. So I'll just go with this. Next, what permission I want to give it to this particular role, and this particular I want to allow S3 full access to AWS. So I want to give, one second, I'll just simply select it here, and I will simply say, okay, I want to give S3 access to EC2. Next, add tags, I will say department, and I will say development. Next, review. So role name, I mentioned role there, S3 access for EC2. So it should be continuous. So I have added S3 access to EC2. So this allows EC2 instance to call S3 service on your behalf. So this is the explanation, and I can go ahead and create this role here. So this role will allow EC2 service to access S3 service as and when required. So as of now, I can just cancel it. Now let's look at the policies. The policies are typically the JSON documents, and let's say what is the policy what we have in the administrator access. So if I click at this, so it shows me the JSON format which says version, some version, and the statement it says allow everything, action on everything, and resources everything. However, if I go and look for other policy, let's say I will look for S3 policy here, Amazon S3 full access. So in this scenario, if we look at this, the action is possible only within S3, and resources are all star. So that means they will be able to do all these things in S3. So they have got full access for S3, right? So what we have here is in action means on what resources this action will be available. Now we'll go ahead again, go to policy and type S3. In S3, I will just go with read-only access, and when I click on this, we see effect is allowed, but action is limited. Action is limited only on S3 get and S3 list. So they will not be able to write anything to S3, but they will be able to read the files or the objects from S3. So this is how we can restrict various kind of stuff in our IAM. So we have in IAM, we have groups, which are group of multiple users. The users, which are actually the human beings or the individuals in a given organization, and the roles, which are typically available for AWS resources so that they can access other AWS resources. And all these three, group, users, and roles, should be given some policies so they are able to do something in your AWS infrastructure. Now, just to understand this, policies are the JSON documents, and they allow you, they make sure what are the authority available for that particular user, that particular group, and that particular role. And one user can be a part of multiple groups. One group can also have multiple users. At the same time, all group, users, and role can have multiple policies assigned to them. So it's not that they can have only one policy, they can have multiple policies for them. So this was a quick demo on IAM. I hope you enjoyed this session. Look forward to see you in the next session. Hello cloud experts. So whenever we talk about computers, the first thing is computer itself. Now let us understand how we build our own computer in AWS cloud infrastructure, and the service for that is called as EC2, which is Elastic Compute Cloud. My name is Sanjay Kumar, and I'm a trainer and consultant on cloud and AWS. So let's get started. Now moving on, what is Amazon EC2? EC2 is one of the oldest service in AWS infrastructure, and it is called as Elastic Compute Cloud. Now let us understand what is EC2. EC2 is nothing but a computer capacity in the cloud, which is resizable, and it is available as a web service. So you can have a compute capacity which is available in the cloud, and you can configure this capacity depending on the requirements what you have. It can scale up and down whenever required. So you can increase the capacity, you can decrease the capacity, and you can also do it automatically by using something called as ASG, which is auto scaling groups. So whenever typical thresholds are met, it will increase your capacity and decrease your capacity whenever your demand is going higher and lower. Supports auto scaling and load balancing. So you can also run multiple EC2 instances for one particular service, and that service can actually be load balanced on multiple EC2 machines, as well as you can also increase the capacity and decrease the capacity whenever these things are required or they are not required. And you pay only for the use what you do for that particular machine. It can be used for hosting websites, can be used for databases, or anything else what a server can do. So this is typically a computer or a server which is available in the cloud, and it can typically do anything which can be done by a server or a computer. Some of those examples can be hosting a website, managing databases, or anything else what we want to do on a particular server or computer. And it is available in a variety of configuration, which is like AMI, which is Amazon Machine Image, which is typically the operating system of the machine, number of vCPUs, what kind of virtual CPUs you need, the RAM, the memory what you need, and the storage capabilities you need for that particular computer. You can configure all these things depending on your requirement. So let's have a look what are the different instance type which is available. So they have something called a general purpose, which is typically A1 family, T family, and M family. Then there are some capabilities, some instances which are typically compute optimized, memory optimized, and accelerated computing, as well as storage optimized. So depending on what are your particular applications, and according to that you can choose different type of instance machine. So if you're doing some graphic heavy work, so you can go with some kind of instances which requires some graphic heavy, some which are typically for G is for typically graphics. So you will go with some G family instances. However, if you need some heavy RAM, so you will go with R family. If you need some heavy compute, then you will go for C family, which is for compute. And for any tiny or turbo applications, you typically go with the T family. So there are various families available. However, out of these, only one is available in free tier, which is typically called as T2 micro. T2 micro is something, one particular instance, which is available for 750 hours in a year for 12 months. So you have 750 hours per month for actually 12 months. So we have various instance type, and we can choose these instances according to the need what we have. So various different type of applications may need various different instance, and this is where this instance type plays an important role. What are the different pricing model for EC2? EC2, the first one is on demand EC2, which is typically pay a fixed rate by an hour or a second. So you have some instances which is available on per hour basis, and some instances which are available on per second basis. So typically the Linux EC2 Linux instances are available on per second basis, and other instances are available like Windows and all available on the per hour basis. However, if you are very sure that you need these capacities for 1 to 3 years, you can actually do a capacity reservation, and you will get a significant discount up to 70% depending on how much you want to pay upfront. And these instances, this pricing model is called as reserved instances. So after on demand, on demand there is absolutely no commitment. In the case of reserved, you need to have some commitment, whether you need to commit for 1 to 3 years, starting with 1 year to up to 3 years, where there will be capacity which will be reserved for you, and you can get up to 70% of the discount depending on the what kind of capacity, what kind of instances you're choosing, and what kind of capacity reservation you're doing, and what is the duration you're using, and additionally how much money you are paying upfront. So you can pay all upfront, you can pay partial upfront, and you can also pay no upfront at all, but you have to reserve this capacity with AWS. Spot instances, which is typically you will bid for the unused capacities and get it at a price what you want. So if you need some very heavy processing capabilities which you cannot afford to buy in on-demand and reserved, you can actually bid for those unused capacities and you can use them only if they are available, and this is where we use something called as spot pricing mechanism. Spot instances typically doesn't guarantee that you will be able to use it, but if they are available you can use them at the price what you want. So you can bid your price and you can use them whenever they are available on that particular price point. Dedicated host, however, if there are some limitations where you want a dedicated machine for your applications, you can also go for dedicated host, which will be typically little costlier than on-demand, reserved or spot, but here you can also use some server-bound licenses. So if your licenses are bound to a particular server, you can always go for dedicated host and can actually use these licenses on a dedicated machine which is available. Now, on-demand, so let us understand, is useful for quickly setting up the servers and deploying your workload. So whenever you want to do something quickly with no long-term commitment and paying only for what you use, you should always go with on-demand pricing. First time use for testing new applications. So every time we are doing first time use or testing some new applications, we should always go for on-demand mode. Reserved is used when we have got some long-term commitment for 1 to 3 years and we can get a discount of up to 70 to 75%. The more you pay upfront, the more discounts you get, and we have something called as convertible reserved instances, which allows you to change the attribute, the instances with some limitations. So there are some reserved instances which are called as convertible reserved instances, which allows you to change the attributes of the instances with some limitations. Spot instances, you can only bid for excess capacity at a lower rate, useful for workload which got flexible timing and applications which requires very low price compute capacities, then only makes sense. It is not suitable for regular workloads or regular jobs. It is large cost computing needs. So this is typically less cost computing needs. So whenever you want to do something at the less cost, so this is just a typo error, so it just read it less cost computing needs. So whenever you have computing needs which requires very less cost, then only you should go for spot pricing. Dedicated host, when you need a dedicated machine for your workloads and for compliance which doesn't support multi-tenancy architecture, and this may be required whenever you use some server bound licenses. Now let us talk about it. There are various compute services which are available, and it comes with the EC2. We will talk about it, but before that we will talk about virtual instances. EC2 machine, which is typically Elastic Compute Cloud. It also comes with something called as storage, which is typically EBS, which is Elastic Block Storage, and we have something called as load balancers. Load balancers are called as ELBs, Elastic Load Balancers, and we have something called as auto scaling groups, and which is called as ASG, auto scaling groups. Now, Elastic Load Balancer, whenever you have two different EC2 running for the same function, so Elastic Load Balancer gives this access and balances the load between two different EC2 instances. The EBS is like the hard disk of this virtual computer. So EBS is typically the hard disk or the storage for this particular EC2 machine. And we have something called as auto scaling group, which can increase or decrease the capacities whenever you need additional capacity and whenever you don't need additional capacity. So it can increase your number of EC2 machines and it can also decrease the number of EC2 machines, and that is typically done by something called as ASG, which is typically auto scaling group. Now, what are the different configuration options? What are the things which are configurable in case of EC2? You can have computing capacities, that means number of vCPUs you can define, how much RAM you need, what kind of memories you need, what is the operating system. You need Linux, Windows, Ubuntu, and it also gives you many customized options from marketplace, which is easily available, so you can use it for various different customized options as well. It is having type of storage, which is EBS, which is Elastic Block Storage, EFS, which is Elastic File Storage, and ephemeral storage, which is typically assigned with the instance itself. It also comes with some features which is called as Elastic Network Adapters, which is actually kind of fixed devices available for your EC2 instance, Elastic IP versus Dynamic IP. So every time you reboot your instance, every time you reboot your computer, it gives you a different IP, which is typically given by the AWS infrastructure. This dynamic IP is actually also a public IP. However, this public IP keeps on changing. So if you really want to have the same IP, you need to go with something called as Elastic IP. So in Elastic IP, you will have a fixed IP assigned to your machines, and as long as you are using that machine, whether you reboot it, whether you stop and start again, every time you will be assigned with the same IP address. This IP address, dynamic IP address, will change every time you reboot your machine, but Elastic IP will not change. It also comes with a lot of configuration related to VPC and security group. We will understand a little more about security groups, and it also has something called as EC2 user data, which is typically called as bootstrap script. So whenever this machine is starting up, if you need to add some bootstrap script to this particular machine, you can always do by using a field called as EC2 user data. In the next session, we will talk about it, how we really implement our EC2 machine. Now, what are the security groups? Security groups are like virtual firewalls which regulates the access to the EC2 instance with some inbound and outbound rules. So by default, nobody will be able to access your EC2 machines until unless you create some inbound and outbound rules, and those rules are actually assigned with the security groups. So they can give access to the certain ports, they can give access from IPv4 or IPv6 addresses, and they can also give this access through some particular IP addresses and only through some other security group. And these rules are like inbound from others to instance and can be outbound from instance to others. So this is like virtual firewalls. They will define all the inbound traffic and outbound traffic to your EC2 machine, which is typically a kind of virtual server. Now, security group will have some inbound rules and some outbound rules. So only those rules will be available to access this particular Amazon EC2 machine. Some popular port numbers, for example, if you want to give SSH access, so I want to access this machine by using SSH, so I need to open 22 port in the inbound rule, or port number 80 for HTTP, port number 21 for FTP, port number 443 for HTTPS, for port number 3306 for MySQL, and port number 3389 if I want to enable it for remote desktop protocol for Windows. So these are some popular port numbers. There are hundreds of other port numbers available, but these are some popular port numbers which are typically used to access your EC2 machine. That's all we have in this session. So let's have a quick demo of EC2 in the next session and look forward to see you in the next session. Hello cloud experts. So let's move forward with a quick demo on EC2. So to do this, either we can look at these recently visited services and click EC2 here, or simply type EC2 in the sign box and click on EC2 here, or go to the services, and in services under compute I can click on EC2. So they will all lead to the same page, which will be the EC2 page. And in this case, as of now, I am in the Northern Virginia region, but I can change the region whatever I want. I can make it Asia Pacific Mumbai region, or US East 1, US East 2, or any other region of my requirement. When I look at this, it gives me a lot of information: running instances, Elastic IP, dedicated host, snapshot. Give me lot of option in the left side of it. As of now, we'll not get into these details, but we'll just see how to launch a new instance. So I will click on running instance. So as of now, there are no instances which are created in Northern Virginia regions. So I may have some other instances running in other regions. So to start with, I will simply click on launch instance. The very first page, when I see, it asks me what is the Amazon machine image I have to choose. Amazon machine image is like an operating system for your machine which you want to create. You can go with the options available here, and if you really want to use only the free tier available versions, so you can simply choose free tier version here. So it will show you all the options which are available only in free tier. However, if you really want to create some machine of your choice, you can always uncheck this and you will get all the options which are available. You can have your own custom made AMIs created which you can use for future machines. You can get it from AWS Marketplace, which are a lot of AMIs available which are on the chargeable basis, and you can also go ahead and get some AMIs in community AMIs as well. So as of now, we'll not get into this. We'll simply quick start and we will go with the free tier option. But as of now, I will just go ahead and we will choose only the options which are available in free tier version. So here also it gives me a lot of options which are available. So I will simply go ahead and select it. When I select the AMI, it asks me to choose the machines which are available. It comes with a lot of families of instances. So for example, we have a lot of families related to general purpose. We have, other than general purpose, we have a lot of other families available as well. Compute optimized, GPU instances, FPGA. As of now, we will not get into these details. We will simply go ahead because only T2 micro is something which is free tier eligible. So micro instances are eligible for the AWS free tier user. So as of now, we will only go with the free tier. So we'll go ahead and launch a T2 micro machine. We'll go next. Now in this case, how many instances I want to launch? So as of now, I will go with only one instance. I can also launch instances in auto scaling group, which we'll discuss in some future sessions. I can also go for spot instances as we discussed. So as of now, we'll not go for spot instances. Now there are two options here. Either I can go ahead and use the default VPC which is created, or I can create my new VPC. At the same time, I can also choose my subnet. So as of now, I'm going only with the default VPC. We will see in the next few sessions how to create your own custom VPC. So we will see either you want to assign public IP to this particular machine or not. So we'll check all these details at a later stage. So you can also, the IAM role what we created earlier, you can also create those you can assign those IAM roles to EC2 machine as well. Shutdown behavior, so you want to stop or terminate whenever these EC2s are being stopped. And there are a number of other options. We'll go ahead and we'll not talk about all these things as of now. So if you have any bootstrap script for this particular machine, you can also type that as a user data. You can do it as text, which you can copy and paste here, or you can also create this as a file. Now next, add storage. We'll move add storage. So by default 8 GB of EBS volume is already attached to it. If you really want to attach more volumes, we can click here and add more volumes here, and also change the size of this particular volume. So EBS volumes are typically like hard disk of EC2 machine. So with every computer, the way we have a hard disk, similarly with EC2 machine we have EBS volumes, which is typically like a hard disk of EC2 computer. Now next, add tags. So we can also add a tag where key is department and the department is development. So we can choose what is the key and what is the value for that particular department. Next, configure security groups. So as of now, we can have multiple security groups. So as we can either create a new security group or we can select an existing security group. So we have multiple security groups here. So in this case, I will create a new security group, which will say EC2 for CTG. Description of this, I will go ahead and use the same description. So we have used a new security group named EC2 CTG, and we are creating some inbound and outbound rules. That means this machine should be available to access via SSH from TCP port number 22 and from any IP address. So what we have done is we have given permissions to access this machine via SSH. We will be able to SSH this machine from anywhere in the world by using port number 22. So let's move forward, review and launch it. Now we will review all these things. So what machine we have chosen, what are the different instance type, the security group, instance details and other stuff, and finally we'll go ahead and launch this particular machine. Now it allows me to choose an existing key pair, or we can have a new key pair available. So in this case I'm just going to create a new key pair, and I'm keeping this new key pair name as EC2.-CTG. So EC2-CTG is the key pair name I'm keeping, and I will simply click here and download this key pair. So we have to very sure when we download this key pair, we keep it safe. Otherwise, if we lost this key pair, we will not be able to log in into this particular EC2 instance. So I'm just downloading it to my computer. So this is downloaded to my computer, and I will go ahead and launch instance. So now I will simply go ahead and go to the EC2 page machine, EC2 page, click on instances, and my instance is now in the pending state. It will have some status checks with 2x2 checks completed. So it will take a couple of minutes. We will pause this video and just come back once this machine is ready. So now our EC2 is up and running. We can see the instance state is running and status check is 2x2 completed. Now we can also click here and change this name to whatever we want. We can have up to 255 characters, and it will go ahead and put this name as CTG. CTG here is Cloud Training Guru. So let's see how we can connect to this state, instance. There are multiple ways to do it. Either I can simply connect here and click on action, connect. It gives me multiple options. So either I can connect it by using EC2 instance connect. So we can have direct connection from EC2 itself. And to do this, we will not need the key which is generated during the creation of EC2 user. So we will simply see our username is EC2-user, and we will simply connect here, and it opens another window where now we are connected to this particular EC2 instance. So we are inside the EC2 instance which we have created, and now we can do whatever we want with this particular EC2 machine. However, let us look at the other option. So as of now I'm created on an Apple Mac. If you are on a Windows machine, you need to download PuTTY and PuTTYGen kind of applications to create the required keys and log in into EC2 machine by using SSH. However, I'm using a Mac. So what I will do is I will simply open a machine, terminal. So I opened a terminal. In terminal, I am on my main drive, from where I will go to the desktop. Desktop is the place where I have stored my key, and this key is stored in a folder called as ctg-key. So I have stored this PEM file in ctg-key. So I will simply go ahead and ls cd ctg.key. If I do ls, I see this file which is created here, which is PEM file, which is ec2-ctg. So we have this file created, stored in, it is created during the EC2 instance, and now it is stored in my folder which is ctg-key. Now before we move forward and connect to this, let's go ahead and just change the permissions for this file so that it should not be publicly visible. So I'll say chmod 400 ec2. So I'm just changing the permissions of this file. So the permission of the files are now changed. And now I will simply go ahead, type ssh -i and the name of the key, and then I will write ec2-user, and I will need the address of this particular EC2 machine. To see this, I will go ahead, I will go to the menu of that EC2 machine, and I can see this. There are two options available here. Either I can go with public IP of this machine, or I can go with the public DNS value of this machine. So as of now, I'm just choosing the public DNS value. I simply copied it from here, go to terminal again, and just simply pasted it here. So what I did here is I need the EC2 user to log in on a public address. That public address is given in your EC2 instance. Instead of public address, I can also use the public IP address. So I will simply go ahead and write enter. And as soon as I click on enter, I am now logged in into the EC2 machine, which is available on a private IP. So if you see this, the public IP was available for my reachability, but inside AWS infrastructure, it is hosted on a private IP address. We will discuss all these things at a later stage in detail when we talk about VPC and security groups and stuff like that. So this is how we can launch our EC2 machine and log in into EC2 machine by using SSH on a terminal application on Mac. There are various other ways to do it. Either you can have through Windows RDP connection, remote desktop connection, or you can do it through PuTTY application, which can be installed either on Mac or on Windows. That's all in this session. Look forward to see you in the next session. Hello cloud experts. So the amount of data is increasing day by day, and that is bringing in new problems to enterprises to store that data. And for that we have something called as S3, which is a simple storage service available in AWS. My name is Sanjay Kumar and I'm a cloud and AWS trainer and consultant. So let us understand what is Amazon S3. S3, which is typically called as simple storage service. So it is basically a simple object-based storage. We will understand what is S3. S3 is a secure, scalable and highly durable storage service. It is object-based storage, so you cannot use it for installing some operating system images and some other limitation, but it is object-based storage where you can store anything else other than the operating system images and few other things. Simple web service to store and retrieve data. So it gives you a URL, and that URL allows you to store data and retrieve data. So you can access this data globally from anywhere, and this is used as a simple web service spread across multiple devices and multiple facilities. The data what you store in S3 is actually replicated across multiple devices as well as multiple facilities, so they will give you high reliability and high durability. What are those terms? We'll talk about it. So it allows you to upload files between 0 to 5 terabytes in size, but in a single write message, you can put up to 5 GB in a single write message, and above 100 MB files, it is recommended to use something called as multi-part upload. So if you have files above 100 MB, it is recommended that you should always use multi-part upload. So we have something called as bucket. Bucket is nothing but something similar to folder. Inside folder, we have something called as files, and these files are typically called as objects. So just to understand, in case of folders are typically called as something called as bucket, and objects are actually the files. So we have files as objects and folders as buckets. Files are stored in buckets, and all these files are actually called as objects. By default, all the files are private. You will not be able to see it from internet, and it will not be available for public viewing. You have to enable these things whenever you create some buckets or some files. And this typically comes with almost unlimited storage. The storage is almost unlimited for S3. S3 have a universal namespace. That means the bucket name what you use should be globally unique. So whatever bucket name, so for example, I cannot use bucket name as Amazon123 because maybe already somebody has already used that particular name. So I will not be able to use that name. So bucket name has to be globally unique. And just to take some examples, http://ctg, which is cloudtrainingguru.s3.amazonaws.com. So this is one of the, whenever you are creating some buckets in Northern Virginia region, you will have this kind of URL which says s3.amazonaws.com. However, if you are creating this bucket in some other region, you will have ctg dot the name of the region and amazonaws.com. So there is a difference. If the bucket is created in Northern Virginia region, it will have s3.amazonaws.com, but if it is in other region, it will have the region ID as well as amazonaws.com with the bucket name. S3 bucket, it allow you to store objects which are typically files into buckets which are typically folders. So it is actually like folders, and inside folder you have file, but in S3 we call it buckets, and inside buckets you have something called as objects. Bucket name should be unique across all regions, all accounts. So one bucket name cannot be used twice. So bucket name has to be very, very, very unique, and it should not be repeated anywhere else in the world in AWS infrastructure. That includes all the regions and all the accounts globally. S3 is a global service, but buckets are created in a region. S3 is a global service, it is available globally, but buckets are always created in certain regions. So that means your data is actually stored in a given region. Bucket name should be no uppercase, no underscore, can have 3 to 63 characters, doesn't contain any IP address, and must start with a lowercase letter or a number. So it doesn't support any uppercase, any underscore, can have 3 to 63 characters, doesn't contain any IP address, and it also should start with a lowercase letter and number. Now, there are various features here. It is built for 99.99% availability. That means this service is always highly available and built for 99.99% availability, but it is guaranteed as 99.9% availability. It also guarantees 99.999, which is typically 11 nines. So we call it 11 nines durability. That means your files are available all the time and it will not be lost in the AWS infrastructure. It comes with something called as tiered storage. What is tiered storage? We'll talk about in the next couple of slides. But tiered storage means you can have different storage tier where you can store your data to reduce your cost and how you access your data. Lifecycle management. So whenever you have some life cycle, what you can do is you can move your data from one type of storage to another type of storage, and you can reduce your cost, and after a certain period of time you can also delete this data from your storage. Versioning, you can have multiple versions of the same file in your S3 bucket. Encryption, it supports multiple types of encryption, encryption at rest as well as encryption at transit. And it also allows you to have something called as MFA delete, where you will not be able to delete it without using a MFA tool. That MFA tool can be a hardware tool or a software application available in your smartphone. So without using that MFA, you will not be able to delete any bucket. So that means it comes up with some additional layer of security where nobody should be able to delete your bucket in your AWS infrastructure. Now, what are the storage classes and tiers and their life cycle? So we have various different type of storage classes. One is called as S3 standard. S3 standard, which is having durability, high durability, which have frequent access. However, if you need something where you need to have something infrequent access and you want to reduce your cost, you can always go with another tier which is called as S3IA, S3 infrequent access. However, if you really don't want to have this particular availability and durability, you can always go with S3 one zone IA. Typically, your S3 data is stored in multiple zones, multiple availability zones. If you really don't want to have that much durability, you can always go with one zone and reduce the cost further. However, if this data is no more required frequently, what you can do is you can store this in the archival, and that archival is called as S3 Glacier. So S3 Glacier is the archival mechanism where you have typically the access time of minutes to few hours, and then we have another version of S3 Glacier which is typically called as Glacier Deep Archive, where you can have access time of more than 12 hours or so. However, if you really want to do all these things manually, what you can do is you can create some lifecycle rules and move your data from S3 standard to S3 infrequent access, S3 infrequent access to an S3 Glacier, and S3 Glacier to delete. Let's say after 12 months, this data should be deleted from S3 Glacier and I will no more be charged for that particular data. However, if you really want AWS to manage all these things automatically, you can also go with something called as S3 intelligent tiering, where this transition can automatically happen based on the algorithms which are available in AWS. Now, just to take an example, if I talk about S3 standards, which have got 11 nines of durability, but if I look at this, the design for availability, let's say there are like availability zones, so it will be stored in more than 3 availability zones. This is again stored in more than 3 availability zones. But if you look at one zone IA, one zone infrequent access, the data will be stored only in one availability zone. So if that availability zone is lost, that means your data will be lost. So this is a quick comparison between all the different storage comparison, and this data is taken from aws.amazon.com S3/storage classes. However, in case of S3, the access is in milliseconds, S3 intelligent tiering milliseconds, S3 standard IA milliseconds. In case of S3 Glacier, the access time can be minutes to hours, and in case of deep archive, it can go up to hours. So this is the typical comparison between the different storage classes. Now, in S3, what are the things you pay for? You pay for the storage, which is typically per GB. You pay for the request for the reads in that particular S3, how you are reading that S3 data. You also pay if you are using storage management. If you are using storage management, there is a pricing attached to it as well. Data transfer pricing, whenever you are transferring data from one place to another place, you pay for that. There is something called as transfer acceleration. In transfer acceleration, you can typically write your data to edge centers, which are typically content delivery networks or called as CloudFront. You can copy your data in the edge centers, and from edge centers, this data can be written into S3. So this is called as transfer acceleration, and you need pay for that as well. And also you pay for cross-region replication pricing. So whenever you replicate your data, replicate your buckets from one region to another region, you pay for that as well. Amazon Glacier and use cases. Typically, Amazon Glacier is a secure, durable and low-cost storage, and retrieval times are from minutes to hours. However, if you really want further the lowest cost, this is low cost, but if you really want the lowest cost, so you have to go for something called as S3 Glacier Deep Archive. So S3 Glacier Deep Archive is something which will give you the lowest cost of storage in AWS infrastructure, where retrieval time of up to 12 hours is acceptable. So you can have up to 12 hours of retrieval time. If that is acceptable to you, you can go with lowest cost storage, which is called as S3 Glacier Deep Archive. We also have some different storage devices which we can use to transfer data from your on-prem data centers to the AWS cloud. They are called as Snowball, Snowball Edge, and Snowmobile. So what are these things? Snowball is typically terabyte scale data, which comes in two sizes, which is typically 50 bytes and 50 terabytes and 80 terabytes. However, if you really need some compute capacity in the Snowball, you go with Snowball Edge, which typically comes with 100 TB of storage and which will have EC2 and Lambda capabilities available in the Snowball Edge. However, if you really need to transfer petabyte scale of data, then you have to go with Snowmobile, which comes in the size of 100 petabytes. So these are some of the storage devices which can be used to transfer data from your on-prem data centers to the cloud infrastructure. Amazon S3 uses, for what are the things we can use Amazon S3 for? We can use S3 for hosting our static website. We can use it for backup and recovery. We can use it for archives. We can use it for hybrid cloud storage whenever you are using your private cloud and you want to use some additional cloud capabilities, additional storage capabilities in the public cloud. You can also use S3 to store your additional data in the public cloud. And you can also use it for data lakes and big data hosting, and you can also use it for disaster recovery mechanism and many more usage of S3. That's all in this session. Next, let's have a quick demo in the next session about the S3. So Thank you for watching this session and look forward to see you in the next session. Hello cloud experts. So let's start, have a quick demo on S3. In this we will create a S3 bucket and put an object in that. To do this, either I can do this from recently visited services, or I can simply type S3 here, or I can go to the services tab here, and under storage I will click on S3. So when I click on S3, the S3 dashboard will open. So here it gives me options to create a new bucket. So I will just go ahead and create a new bucket. Please note, the bucket name should be globally unique across all your accounts and all regions of AWS. So this should not be repeated anywhere in the AWS infrastructure. So I'm just using a name called as CTG-123. CTG here is Cloud Training Group -123. However, S3 is a global service. We will understand what do we mean by that. But the buckets are actually stored in some of the regions. So either I can go for US East, which is Northern Virginia region, or I can go with Asia Pacific Mumbai region. So depending on the region, they will have one particular URL which will be slightly different from one region to another region, which we'll discuss later. So as of now, I'll go ahead and I'll just go with US East, Northern Virginia region. So let's move forward. What is next? So it gives me a lot of options which I'm not getting into as of now. So it gives me object versioning, different kind of versioning, server access logging, tags, object level logging, default encryption. So I'll not get into all these details as of now. Click on next. Now whether you want to make this bucket public or you want to make it private, so we will, as of now, we will block all public access. So we will not enable it. So it will allow all the public traffic as of now. So let's move forward. So as of now, let's say I'm just go and disable all public access as of now. Let's move forward. Now it is the review page where I will check all the details what I filled. I have kept a bucket name which is CTG123, region is US East Northern Virginia region, and I will simply go ahead and create this bucket. Okay, so let me go back. There are some issues because I created this bucket few minutes back, and now I am just typing it as CTG1234. This is another bucket. Let's move forward. Let's go ahead and then click on next and create bucket. So my bucket is now created. This is CTG1234. There was some conflicting operations, so it was not able to create CTG123. So we have created CTG1234. Now I'll click on this particular bucket, and now I will upload a object in this. So buckets are like folders and objects are like files. So let's go ahead and click on object. So I will choose files. I'll just go in a folder where I've stored the required file, which is CTG S3 object. So this is the file which is I have. Either I can go ahead and upload. It will take all the default settings, or if I want to change some settings, I can click on next. So this is giving me some details, manage users, access. I can also allow access of these objects from the other AWS accounts, which I can add here, and also I can manage public permissions for this particular object. Let's move forward. Here it gives me an option to choose various type of storage classes. So according to my requirement, I can choose the different storage classes. As of now, I'm going with standard, which is frequently accessed data, and it also gives me option like intelligent tiering, standard IA, standard infrequently access, one zone IA, glacier, deep archive, and reduce redundancy. So these are the various options we have, and as of now I'm going with only standard storage class. So this is all what we have, the review page, and where we will see all these details. We'll go ahead and upload it. So it shows our object is getting uploaded. So it takes some time, a few seconds to get it uploaded, and once it is uploaded, we'll move forward. So our object is now uploaded, and we can see this object here. When I click on this, it gives me object URL, which is https://ctg123, which is my bucket name, and .s3.amazon.aws.com. However, if we are using some other domain, other region than Northern Virginia, it will give me some slightly different URL name. Why it is a global service? Because these objects are available as a universal namespace. So I can just go ahead and copy this URL, go to another tab, simply put this object URL, and when I try to open this, it gives me a access denied error. Why we are getting this error? Let us understand. So for that, because this object is not a public object, so we have to go back to Amazon S3, click on the bucket, click on permissions, and now we have to enable our public access to this particular to this. We have to type confirm here. So once we enable public access to this bucket, now I will go back to bucket again. I will open the object, and once I click on object, it will give me an option called as make public. So I will make this object public. So I will copy this again, or I will simply refresh the tab what I have created. So I will simply copy the URL here, which I have already done. I'll click on next, and here we go. So our object is now available on our S3 bucket. So simply we can use this S3 to host some websites and some static data, that is video, audio, or something like this. We can check a lot of stuff related to objects here, the properties of the object. We can change the storage classes, encryption mechanism, metadata of that object. We can also see the tags and object log. We can also see a lot of permissions related to the objects, to whom these permissions are given, and there are some other options related to select from and other stuff. Now we'll go with the bucket. In bucket also there are a lot of permissions available. You have, this is the overview page. The properties of the bucket, we can define some versioning, which we'll discuss in some next sessions. Server access logging, we can also use it for static website hosting, object level logging, and some default encryption for this S3 bucket. It will be applicable on all the objects which are stored in this S3 bucket. We can also define the permissions. In permissions, we have block public access, we have access control list, object ownership, we have bucket policy, and we have some CORS, which is cross origin resource sharing options. So we'll talk about all these options in later sessions, but these are the multiple options which are available. So it has access control list, object ownership, bucket policies. We can define some policies specific to this bucket, or CORS, which is cross origin resource sharing options. We also have a lot of options in the management, where we can create life cycle rules for the objects of this bucket, and the access points, where we can create some access point which we can be used to provide access to this particular bucket. So this is what we have. Whenever we want to go back, you can simply click on the bucket name, object name, copy this URL which is mentioned here, and you can use this for various purposes. And this URL here is a universal namespace, and you can make it public. You can make this object public or non-public depending on your requirement. If it is not made public, you will not be able to use it. So if you really want to delete it, so we can simply go back to the bucket, click on this particular object, and choose an action. Which action can be to delete this particular object, or we can simply go to Amazon S3, click here, and click on delete. When we want to delete this, it will ask us type the name of the bucket to confirm deletion. We will simply type ctg-1234 and confirm it. Once we confirm it, this object will be deleted from our AWS infrastructure. That's all. We have a quick demo about S3. I hope you enjoyed it. Look forward to see you in the next session. Hello cloud experts. Databases are important part of any cloud infrastructure. So in this section, we are going to talk about databases. Typically in AWS, we call them RDS, which is a relational database service, and DynamoDB, which is non-relational or kind of NoSQL database services. My name is Sanjay Kumar, and I'm AWS and cloud trainer and consultant. Let's move forward. In relational databases, what are typically relational databases? Relational database is the one that store data in some kind of tables. The relationship between each data point is clear, and searching through those relationships is relatively easy. However, the relationship between tables and field types is something called as schema. For relational databases, the schema must be clearly defined, and here is one particular example. The easiest way to look at the databases are like some spreadsheets, like where we have some fields which is like ID, first name, last name, and the age. And every row will have all these 4 fields available. However, if we really want to have different fields for every row which is available, the relational database may not be sufficient, and we may need to go with something called as non-relational databases. So non-relational databases is any database that does not use the tabular format, tabular schema of rows and columns like we use in relational databases. It will have a storage model which is optimized for the type of data which is being stored. Non-relational databases will have something called as collection, and that collection will be similar to table, not exactly similar to table, but something relevant to the table. In that collection, they will have some documents which are typically similar to the rows, and every row will have something called as key value pair, which is simply the fields of that particular row. So we have collection similar to table, document similar to row, and the key value pair which is like fields. However, the key value pair for one row and the another row can be different. However, in case of relational databases, all the fields of one particular row should be the same. Now, typical non-relational databases if we see, so we have key value 1001 and 1002, and if you look at the content of the key value pairs for these things are actually different. The content of these different keys are actually different. They are not same. So in AWS, we have a service for relational databases which is typically called as RDS, which supports 6 different database engines which are typically named as Microsoft SQL Server, Oracle, MySQL, PostgreSQL, Amazon Aurora, and MariaDB. So all these SQL Server, database engines are supported in RDS. Out of these, Aurora is something which is AWS proprietary, and it is one of the fastest database which is available in RDS. So we have 6 different database engine. So it supports almost all these. It supports all these 6 database engines, and we can implement all these 6 database engines on our RDS infrastructure. If you really need more database engines other than these 6, you can still do it by using some EC2 machine and configuring those machines as some database servers. But if you really want to use the RDS, you need to use one out of these 6 database engines. Now, what is Amazon RDS? Amazon RDS is a fully managed web service. So it is a fully managed services where you need not to manage the services, you need not to manage the servers, but simply need to create. So you can simply set up, operate, and scale a relational database in the AWS cloud. So Amazon RDS is a fully managed services. It provides cost efficient, resizable capacity for an industry standard relational databases. So again, it will also give you some instance size similar to the EC2, and you can choose the capacity which is required for one particular applications in your network. So you can have resizable capacity for Amazon RDS as well. So typically a RDS comes with 2 different features. One is called as a multi-AG and another one is called as read replica. Multi-AG is something which is used for something called as disaster recovery. Disaster recovery, whenever one particular availability zone is gone, you have the RDS instance available in multiple availability zones, and other instance in different availability zones can come up and serve for your databases. However, if you really want to improve the read performance, then you can go with read replicas, and these read replica is only one is as a master instance, and all other are just working as a read copies of that particular main instance or the master instance. Now, a quick overview about DynamoDB. What is DynamoDB? DynamoDB is a flexible and fast NoSQL server. It provides consistent single-digit milliseconds read or write. So whenever you want to have very fast read and write in AWS infrastructure, and you need to have consistent read and write, in that case you can go with some databases like DynamoDB. Suitable for mobile, apps, gaming, edtech, IoT, and many other applications. Data stored on SSD storage and spread across 3 different data centers. So all the data of DynamoDB is stored in SSD storage, and it is spread across 3 different data centers. It can scale to massive workloads, and it is also a serverless. It is low cost, and it also has something called as auto scaling capabilities. That's all in this session about databases. We will have a quick demo of RDS in the next session. Look forward to see you in the next session. Hello cloud experts. So let's have a quick demo on RDS. We can do it from the recently visited services. We can type in here, or we can simply go to the services, and then the services we will have databases somewhere here. And the databases on top, what we see here is RDS. We'll click on RDS. It will take us to the RDS dashboard or RDS main page. So here it shows Amazon Aurora, which is the Amazon proprietary database. We can just simply cancel it. We can click on DB instances or click on databases here. So as of now, there are no DB instances running. So we'll see here, there are no instances which are created. Let's go ahead and create a RDS instance. So we'll simply click on create database. So either I can have two options here. Either I can go with the standard create, which is going to be easy standard create, which will allow us to have multiple options, and easy create will create a easier option. So as of now, we'll go with standard create. Engine type, it gives us 6 engine type options, which is like Amazon Aurora, MySQL, MariaDB, PostgreSQL, Oracle, and Microsoft SQL Server. As of now, we are just going with MySQL. Now, where here we see the multiple versions of MySQL. I'm just going with the default SQL version, which it is showing. I want to create it for the production or for some development and testing or for free tier. As of now, we don't want to spend any money here. So I will simply go ahead and click on free tier. It will grey out some of the options which are given below, but as of now, we'll go only with the free tier option. Now, when we'll click on this, we will simply create a database instant identifier. So I'll click CTG DB 2020 is the name of the instance I've used. I'm using the same name for the username, the master username, CTGDB 2020. I'll use this for the password and also for the confirm password. So I'm using CTGDB 2020 for the username and password. The instance size, it will not allow me to choose other options because I have chosen for the free tier version. Otherwise, all these options will be available. It allows me to use what kind of storage type I want to go for, or what kind of allocate storage. I can also change this part. Now, maximum storage threshold, multi-AG deployment, because I'm going with free tier, it doesn't allow me to go with multi-AG deployment. It gives me multiple option of RAID replica or some kind of disaster recovery mechanism. So I'm going to create this in my default VPC itself, and I will go with password authentication, and it also gives me some information about estimated monthly cost, but because I'm using free tier version, it will not charge me anything, so it will be free for me. I'll go ahead and create database. So now what I see here is the database being created. Database creation takes a little more time than the EC2 machine, and we will wait for this to come up, and then we will move forward with the further video. Now our CTGDB 2020 is up and running, so it says available here. I can simply click on this and see multiple details here. So it shows the endpoint. That endpoint will be used for accessing this particular SQL server. To do this, we need to have another EC2 service running with the EC2 SQL client, and we can log into this SQL server by using a SQL client. Hello cloud experts. You need your own personal space in the cloud infrastructure, and that is where the virtual private cloud comes into play, or we call it VPC, which is typically virtual private cloud. Now, my name is Sanjay Kumar, and I'm an AWS and cloud trainer and consultant. What is VPC? VPC, which is known as virtual private cloud. It is actually a virtual private network in the cloud. It lets you provision a logically isolated section of the AWS cloud infrastructure where you can launch your AWS resources. So it is actually a private network which is created within the AWS cloud infrastructure, and within that VPC you can launch your AWS resources. It gives you complete control over the virtual networking environments. So it is basically a networking environment which is virtual. It including selection of your own IP address range, the creation of subnets, and configuration of route tables, and the network gateways. So basically, you can do everything in the virtual private cloud, which is typically you are doing in your own private network. So where you can choose your own IP address, create their subnets, and also configure route tables and network gateways and a number of other stuff. Now, we can use both IPv4 and IPv6 in our VPC, and we can have secure and easy access to the resources and the applications. Now, you can easily customize the network configuration of your Amazon VPC. For example, we can create a public facing subnet for our web server, or we can create a private facing subnet, which is for typically we use for the databases. We can also have our backend system like databases or application server in a private facing subnet, which will not have any direct internet access. We can also have multiple layers of security, including security groups, the network access control list or NACL or NACL we call it, and help control access to the Amazon EC2 instances in each subnet. So we can have multiple level of security with the security groups, NACLs, and we can allow who should be able to access EC2 instances and other AWS resources. Now, just to take an example, this is a region which is AP South 1, and within this region we have a VPC created. Within this VPC, we have defined the name of VPC defined as CTG, which is Cloud Training Guru, and here we have 10.2.0.0/16. Now, we are giving access from the outside world by using something called as Internet Gateway. Internet Gateway allows you access to these resources by using through internet, which is actually getting into something called as route table. Route table defines all the routing entries where you will be able to route the traffic in your network. After that, it goes through something called as network ACL, which is also called as NACL. NACL defines some kind of rules which should be available to give you access to this particular subnet. And from this subnet, you have typically two SGs, which is called as security group 1 and security group 2, and they will have their own rules to give access to the instances which are part of that particular security group. So you have basically two levels of security here, actually three levels of security. One is internet gateway, which is typically not the security part of it, but gives you access to the internet, and the network ACL, which is NACL, and the security groups, which are having some inbound and outbound rules to give access to these EC2 instances. In these security groups, you can define access based on the port wise. You can also do it based on the IPv4 or IPv6, or you can also do it by using some port numbers, what exactly you want to use. You can also assign an IP address from where people will be able to access this particular EC2 instance. What are the things we can do with the VPC? We can create our own VPC. We can assign IP address range of our own choice. We can define some security groups. We can create custom subnets, and we can launch instances with custom subnets. And we can define subnet network access control list, which is typically the access control list for a particular subnet. And we can have enhanced security feature compared to something called as default VPC. We always have a default VPC created, and if we want, we can use that. But if we really want to have enhanced security features, we can create our custom VPC, and we should always launch our workload in the custom VPC itself. Using default VPC may expose some of your resources to the internet, which you may or may not need. That's all in this session. In the next session, we will talk about a quick demo on VPC, and look forward to see you in the next session. Hello cloud experts. So let's move forward with a quick demo on VPC. To do that, we can click on VPC from the recently visited services. We can type in VPC here, or we can go to the services tab, and in that we will have networking and content delivery here, and on top of this we will have VPC. So we'll simply go ahead and click on VPC. It will open the dashboard for the VPC. We can see various information here. It can show me all the VPC across all the regions. So by default, one VPC is created in all the regions. We can look at as of now we are in Northern Virginia region, so but you can choose the closest region to you. So in this case we are clicking on your VPC. It will show me the default VPC which is available here, subnets in this particular VPC. So as of now it has created 6 different subnets in this VPC. The route tables, different kind of route tables it has created, the routes of in those tables, what are the rules created in those tables. It has also created one internet gateway, and if you go down we have a lot of other options here, carrier gateways, DHCP option set, elastic IPs. Here we will look at 2 more details, network ACL and security groups. Now let's move forward and create a new VPC. To do this, simply we'll click on your VPC and create a new VPC. Now in this case what we are doing is giving a name for the VPC, CTG-my VPC. My VPC. So I'm just giving a CIDR block which is like 10.0.0.0/16. Either we want to use some IPv6 block, we can choose those options. Multiple options, no IPv6 CIDR blocks, Amazon provided IPv6 CIDR blocks, or some IPv6 CIDR block owned by me. So as of now I will go with no IPv6 CIDR block. Default options, I can go in tenancy option, I can go for either default and dedicated. In case of dedicated, you will get a dedicated host available for you, but that will cost you use, so we'll go ahead with only default tenancy. We'll go ahead and create VPC. Our VPC is now created. Now we can see 2 different VPC here. One is CTG-my VPC, which is created by me, which has a VPC ID ending with A is 5. We will talk about it, why we are talking about it. In the CIDR block, what we see here is 10.0.0.0/16. Now if you look at subnets, we will not have any subnets created here, so it has only the old subnets available. We can look at the route tables. If you see this, we have already created a new route table, and we will have the VPC ID ending with AE6. So we have created a new route table based on the new VPC. Internet gateway. So internet gateway is also not created. Only one internet gateway is created. That is the older one. If we look at network ACL, we have one new network ACL created, which is belonging to CTG-my VPC. And security group, we have one more security group created, which is belonging to the new security, which is VPC ID with ending with AE5. So we have new security group created, new network ACL created, and some other details like route tables and other stuff are created. Subnets are not created. So we'll move forward and we'll go with subnet and create a new subnet. So in this case we are just giving subnet 1 is the name we are giving. VPC, we have to choose the VPC, so we'll choose the new VPC what we have created. Availability zone, if we want to give some preference for the availability zones, we can give that, otherwise we can leave no preference. So it will by default create a subnet in one of the availability zones. As of now I'm choosing US East 1A. CIDR block which is associated, out of that I will go with CIDR block of 10.0.0.1.0/24. So subnet mask I have chosen as /24 and starting with 10.0.1.0. So this is one what I have created. I've created subnet 1 with VPC, the new VPC, the availability zone I've chosen, and I'll go ahead and create it. So my subnet is now created. Now if we see here, we have created one more subnet here. So this was a quick demo about how to create a new VPC and how to create a subnet inside that VPC. That's all in this demo. We'll have some more details about further procedures or further functions of VPC in the later section. Look forward to see you in the future sessions. Hello cloud experts. So routing traffic to the right resources in public cloud infrastructure is very important aspect, and hence we have this service called as Route53 or Route 53, which is typically a DNS service, and the Route 53 names comes from Route 66, which was one of the first superhighway in United States of America, and the port number 53, which is typically used by DNS. So DNS port is port 53. In this session, we are going to talk about Route 53. My name is Sanjay Kumar and I am an AWS trainer and consultant. Now, what is Route 53? Route 53 is a DNS service from AWS. DNS is a service which converts our domain names into IP addresses to keep it simple. However, it is much more than that. But in the simple manner we can understand it, typically converts my domain name into a IP address. IP address can be IPv4 or IPv6 as well. Route 53 have various types of records, which is called as SOA, start of authority records, NS, which are typically the name server records, which are typically used to redirect your domain name to some kind of name servers. A record, which resolves your domain name to an IPv4 address. A record, 4 times A records, which is resolving domain name to IPv6 address. C name, which is called as canonical name, which is resolving one domain name to another domain name. And alias record, to map resources to ELBs, CloudFront or S3. For that, what kind of records we are going to use is called as alias record. Also, Route 53 have some routing policies, and these routing policies can be found on this particular link, which is from aws.amazon.com. Some of these routing policies are called as simple routing, failover routing, weighted routing, geolocation routing, geo-proximity routing, and latency based routing. So your traffic, if you have multiple resources available for the same service, the incoming traffic can be routed to different resources depending on the routing policies what we have used here. Simple routing, failover routing, whenever one particular resource is failed, it will be routed to the another resource. Weighted routing, you can have some kind of weighted routing to different resources. Depending on the geolocation and geo-proximity, this routing can be done. And also, you can always route your traffic where you have minimum latencies. So there are various routing policies. And multi-value answer routing. So you can also support something called as multi-value answer routing as well. That's all in this session. In the next session, we will have a quick demo on Route 53. Look forward to see you in the next session. Hello cloud experts. So let's move forward and have a quick demo with Route 53. So you can do it from the recently visited services or simply type Route 53 here, or you can go to the services tab and under networking and content delivery, you will see the Route 53 just after CloudFront. So here we will click on Route 53. So in this we can see multiple hosted domains. So we can just click on hosted zones. You'll see here multiple hosted zones what we have. Now in this case, we'll create a new hosted zone. The domain name what we want to transfer. So here it is ctg-123.com is something what we actually is our URL, where this is the name of the domain that we want our route our traffic for. So we are going with only public hosted domain as of now, but you can also have private hosted zone. So I will simply go ahead and create a hosted zone. So it has created one more hosted zone here, and when I click on this, I will simply go to this particular hosted zone and we will just go into the create record option. When we go with create record option, it will give us multiple options for choosing our routing policy. Routing policy is basically how you route traffic to the various resources available in AWS infrastructure. So there can be simple routing, which will be available if you're routing traffic to just one resource such as web server, or weighted one, or geolocation based routing, or latency based routing, or failover routing, as well as multi-value answer routing. Now these are the different routing mechanism what we have available, and as of now we are just going with the simple routing mechanism. We'll go ahead and click on next. So we have to create some simple records here. So we'll create define simple records. So here we'll go with this, either we can type www.ctg.123.com, or we can simply also have some domains under the same domain name what we have created. We can also how you want to route our traffic. So as of now, we want to route our traffic to a IP address or another value depending on the record type. So we have created multiple records here. So in this case, we are going with multiple records. So what are the different multiple records we have? As of now, we have this A records, which is typically route traffics to an IPv4 address and some AWS UC name when we want to route traffic to another domain and to other AWS resources, MX, TXT, and a lot of other options here. So as of now, we'll go ahead and do the create A record. Now we have to put an IP address here. To do this, we will go to the instance page. So this is the instance that we have created, and in this instance page, we have IPv4 public IP address. So we'll click on this particular IP address. We will copy this IP address and we will paste this IP address here, and we'll go ahead and define a simple record. So our record is now created. Now if we look at this, we'll go ahead and we'll go ahead and create records. Our records are being created. So in our hosted zone, which is CTG123, we can actually have different records. So it has multiple records here. It has CTG SOA, which is start of authority record, NS record, which is name server. So whenever we are routing some traffic to this particular hosted domain, we can use these name servers which are available here. It gives you 4 different domain names and with the different top level domains like .uk, .co.uk, .org, .com, and we have one of the .NET domain here which is available here. So we will give these name servers to our hosted domain. It also gives us a type of record which is created here, and also the SOA, which is start to 30. So this was a quick demo on Route 53. We have so many other details to cover on Route 53, which we will do in some future session. Thank you very much and hope to see you in the next session. Hello cloud experts. So now we have got good idea about EC2, and we have also seen a quick demo on EC2. So let's talk about some other compute services. So in this session, we're going to talk about some other compute services including EC2. My name is Sanjay Kumar and I'm a AWS and cloud trainer and consultant. Now, what are the different services in the compute? EC2, which is called as Elastic Compute Cloud, Elastic Beanstalk, AWS Lambda, and Lightsail. Now, out of these, we have already discussed about EC2 and we have also seen a demo of EC2. In this section, we're going to talk about Elastic Beanstalk, Lambda, and Lightsail briefly. We'll understand what are these services and for what are the different things where they are being used. So Amazon EC2 is the Elastic Compute Cloud, which is a web service that provides resizable computer capacity in the cloud. It can scale up and down when required with the support of auto scaling and some other features like load balancing. Pricing can be on demand, where you can deploy the services and pay per minute or per second or per hour. It can be reserved, where you will have some 1 to 3 years commitment and you will pay very less amount, and you can have up to 75% of savings compared to on-demand instances. And then there is something called as spot pricing. In case of spot pricing, you typically go with bidding for some particular resources. It is useful for the workloads which requires very less computing cost, and you can bid for the additional capacity which is available and the services which are not having time constants. However, if you really want to have some dedicated capacity, in this case what you can do is you can also go for a dedicated server, and that one particular machine will be dedicated for you. It is required when you have some compliance that your machine should be fixed, or you have some licenses which are hardware bound. In those scenarios, you can go with something called as dedicated host. Now let's have a quick review on Elastic Beanstalk. Elastic Beanstalk is kind of PaaS, which is called as a platform as a service. So as we understand, the cloud computing have 3 different service models, which are called as infrastructure as a service, platform as a service, and software as a service. So we can categorize Elastic Beanstalk in the PaaS. It allows us to deploy and scale our web application without getting into platform setup. So it is easy to use service where you can deploy and scale your web application without getting into the setting up your platforms. So platform supported, it supports some platforms like Java, .NET, PHP, Node.js, Python, Ruby, Go and Docker. So these are the various platforms which are being supported by Elastic Beanstalk. We have servers such as Apache, Nginx, Passenger and IIS. It orchestrates various AWS services. So whenever we create a workload on Elastic Beanstalk, it will automatically communicate with other services that includes EC2, S3, simple notification services, which is also called as SNS, CloudWatch, auto scaling and elastic load balancer, and it will create all these resources automatically depending on what is required for your web application. So it will do all the background work automatically, and it will simply give you a platform where you can quickly deploy your codes without needing of setting up the infrastructure, or I'll say platform. We can quickly deploy our codes without getting into setting up our environments or without setting up our infrastructure. We can directly deploy our code by using Elastic Beanstalk. So Elastic Beanstalk is easy to use service where we can deploy our applications. Lambda or Amazon Lambda, it is actually a serverless computing platform, and in this case it lets you run your codes without actually provisioning or managing servers. So in this scenario, you need not to run code, or you just need to run your code without provisioning or managing any server. In case of Elastic Beanstalk, you still need to provision your servers, but in this case you don't really need to provision or managing your servers. You pay only for the compute time you consume, and it is an event trigger event. So it is an event trigger function. So AWS Lambda is the event driven computing service that runs code in response to events and automatically manages the computing resources required by that particular code. So you don't really need to set up any infrastructure which is running all the time, and that infrastructure will be created only when there is an event trigger, and you will be paying only for the resources what you use. However, this will help you to reduce your cost drastically because your computing resources will be created only when there are some triggers and events. So it will help you a lot to reduce your cost, and that is why the serverless is getting popular day by day, and more applications have started using Amazon Lambda. Lambda is the best way to get started with something called as microservice architecture. So microservice architecture is a very important aspect of cloud computing infrastructure, and this is the best way to get started with your microservice architecture. Lightsail, if you really don't want to get into the complexity of so many servers, storage and other networking components, you can simply get started with something called as Lightsail. Lightsail is a service which helps you to quickly deploy a simple app or web without getting into complications of various resources like compute, storage, networking, etc. So the easiest way to get started for setting up your server is Lightsail in AWS. It comes with a nominal fee per month depending on the capacities or feature you need. So it will have a fixed fee per month depending on what are the capacities or features you are using on the AWS infrastructure. If we are new to cloud or looking to move to cloud quickly, Lightsail is the best and the easiest option. However, it can be used for web application, websites, business softwares, and development or test environments. So it is suitable for web application, running your websites, running your business softwares, or development and test environments. That's all for this session. Look forward to see you in the next session. Hello, cloud experts. So in the past few sessions, we have talked about S3, which is simple storage service, and we have also seen a quick demo of S3. Now let's talk about some other storage services. My name is Sanjay Kumar and I'm a cloud trainer and consultant. Now service storage, what we have here is S3, which is simple storage service, also known as S3, EBS, Elastic Block Storage, EFS, which is Elastic File Storage, and S3 Glacier. So these are the 4 different storage types. There are many more, but here we are going to talk about mainly these 4 storage services. Now S3, we have already seen a detailed session on that and also seen a quick demo of S3. Now what is S3? S3 is a secure, scalable and highly durable storage. It is a object-based storage. It is a simple web service to store and retrieve our data. The data is spread across multiple devices and facilities. Facilities here means data centers. The devices here means some different servers. It allows you to upload files between 0 to 5 TB in size. The files are stored in buckets and it gives you unlimited storage, and it comes with a S3. S3 comes with a universal namespace. That means every bucket name should be unique for all regions and all accounts. So you cannot repeat any bucket name in the complete AWS infrastructure. So this S3 bucket should have the standard name which should not be replicated across anywhere in the AWS infrastructure. These buckets are like folders, and inside buckets we have something called as objects, which are nothing but something similar to files. So we have bucket where we have folders and objects which are like files. Now let's talk about EBS, Elastic Block Storage. Elastic Block Storage provides persistent block level storage volumes for use within Amazon EC2. Just like any computer, whenever we talk about any computer needs something called as hard disk. So EBS, Elastic Block Storage, is like a hard disk of the Amazon EC2 computer. So Amazon EC2 computer, which is Amazon EC2 instance, typically requires some storage, and that storage is Elastic Block Storage. It typically works like a hard disk for your servers which are running on your EC2. We can have more than one EBS volume, just like we can have multiple partitions of our hard disk, or we can have multiple hard disks with our computer. Similarly, we can have multiple EBS volumes for one particular EC2 machine. It can be used by Amazon Relational Database Services. Even RDS service of Amazon can also use Elastic Block Storage. Amazon EBS provides a lot of options for storage performance and cost. So there are various options available, what kind of EBS you want to use, and according to that there will be different performance and the different cost. It comes with a lot of storage options like general purpose SSD, IOPS provision SSD, throughput optimized SSD and cold SSD. So depending on what kind of data, what kind of applications you want to use, you can go with different kind of storage option for general purpose SSD, IOPS provision SSD, throughput optimized SSD and the cold SSD. So there are various storage options in Elastic Block Storage. This is typically like a hard disk of the Amazon EC2 computer. Now the next one is Elastic File Storage. Elastic File Storage is typically designed to provide massive parallel shared access to thousands of Amazon EC2 instances. So if we typically EBS is restricted to one particular EC2 instance. So just to give an example, one EC2 instance can have multiple EBS, but those EBS are tied to only one particular EC2 instance. However, sometimes your EC2 instances want to access a shared file system, and in that case we have to go with EFS, which is Elastic File Storage, enabling our application to achieve high levels of aggregate throughput and consistent levels of IOPS with lower latencies. So if we really want to have shared access and have higher aggregate throughput and higher level of IOPS with lower latencies, we can go with Elastic File Storage. Elastic File System is a cloud storage service to provide scalable, elastic, concurrent with some restriction, encrypted file storage for use with both AWS cloud services, and also you can use it for on-premises resources as well. And EBS can be used only with a single EC2 instance as we spoke earlier, but EFS can be used with multiples of EC2 instances. Amazon Glacier and use cases. As we see, Amazon Glacier is typically the cold storage and it is typically used for archival. It comes with two different versions. One is called as S3 Glacier and another one is called as S3 Glacier Deep Archive. Both are actually secure, but they come with low cost storage and retrieval times from minutes to hours for S3 Glacier. However, if you really want to have lowest cost storage where retrieval time of 12 hours or more is acceptable, you can go with S3 Glacier Deep Archive. So just to summarize, S3 Glacier Deep Archive is the lowest cost storage what you can get in Amazon or AWS infrastructure. So this is the lowest cost, but for typical archival, you can also go with S3 Glacier where you can have retrieval time from minutes to hours. That's all in this session. Look forward to see you in the next session. Hello cloud experts. Databases are an important part of our cloud infrastructure. And now in this section, we are talking about various database services in AWS, including RDS, which is Relational Database Services, and DynamoDB. My name is Sanjay Kumar and I'm a cloud trainer and consultant. Let's move forward. So in this section, we are going to talk about RDS, which is Relational Database Service, DynamoDB, which is Non-Relational Database Service, Redshift, which is Data Warehouse, and Elastic Cache, which is a caching service. However, in the past few sections, we have also talked in detail about RDS, and we have also seen a quick demo of RDS. And here we are going to talk about RDS quickly. RDS is a fully managed web service which allows you to set up, operate, and scale a relational database in the AWS cloud. It provides cost-efficient, resizable capacity for an industry-standard relational database. It supports 6 different database engines, which includes Microsoft SQL Server, Oracle, MySQL, PostgreSQL, and Amazon Aurora, as well as MariaDB. Out of these, Amazon Aurora is a Amazon proprietary database engine, and all others are from different companies, but it supports all these 6 database engines. If you really need to have any other database engine, what you can do is you can deploy your databases on EC2 machines, but that you have to manage automatically, where RDS provides you the fully managed services which can manage all these services automatically. DynamoDB is a NoSQL database. It is flexible and fast. So whenever you want to have quick transaction in a single millisecond kind of latencies, you have to go with some kind of NoSQL databases, and that's where DynamoDB comes into picture. It provides consistent single digit millisecond read or write kind of operations, suitable for mobile, app, gaming, edtech, IoT, and many other applications. Data stored on SSD storage and spread across 3 different data centers, can scale to massive workloads and serverless. So this does not require any compute capabilities. It is a serverless architecture and it can scale up to massive workloads, and it is low cost and it has the auto scaling capabilities. Redshift is a data warehouse which is a part of AWS cloud computing platform. The name meant to shift away from the Oracle, which is represented by the red color. So typically the Oracle databases which are defined by red color, they say shift from red. This is typically called as Redshift, which is a data warehouse product of the cloud. Redshift is considered as world's fastest cloud data warehouse and getting faster day by day. For performance intensive workloads, you can use the new RA3 instance to get up to 3x performance of any cloud data warehouse. So as we mentioned, Redshift is actually considered as world's fastest cloud data warehouse, and you can get up to 3x performance of any cloud data warehouse which is available. It can support tens of thousands of customers using Amazon Redshift. Elastic Cache is a fully managed Redis and Memcached in-memory data store and cache services by Amazon Web Services. The service improves the performance of web applications by retrieving information from managed in-memory caches instead of relying entirely on slower disk-based databases. So it is actually required to improve the performance of the web applications where you can retrieve your data from in-memory caches. And in Amazon Elastic Cache is a popular choice for real-time use cases like caching, session stores, gaming, geospatial services, real-time analysis, and queuing. Seamlessly deploy, operate, and scale popular open source compatible in-memory data storage in cloud. So that is where Elastic Cache comes into play. That's all about this session. Look forward to see you in the next session. Hello cloud experts. So we have already discussed IAM and a detailed demo on IAM. Now here we are going to talk about some other security services. My name is Sanjay Kumar and I'm a cloud trainer and consultant. So let's move forward. So in this case, we are talking about services which are related to security, identity and compliance. And here, the first service what we have already discussed is called as IAM, which is Identity and Access Management. We have Guard Duty, which is another service, Inspector, and WAF and Shield. Out of these, we have already talked about IAM, but let's have a quick review on IAM and then we'll move forward with other services. IAM manages user and their access to the AWS resources. So who should be able to access your AWS resources as a user or as an administrator? So we can define that by creating some users and assigning some privileges to those users so they will be able to configure, reconfigure, change or delete your AWS resources. What it offers? It offers you a centralized control of your AWS account, shared access of multiple users within the same organization, and giving some granular permission to those users whether they are allowed to do only certain part of your things which can be done with the AWS infrastructure. It also allows you to have identity federation as well as MFA, which is called as multi-factor authentication, and it also integrates with many other AWS services. So IAM have mainly four terminologies which are called as user, groups, policies and roles. Out of these, first we will talk about the users. Users are the end users who are trying to access your AWS infrastructure, and those users will have certain permission how and what they can do with that infrastructure on the AWS. However, if you have many users which requires the same permissions to access those AWS resources, we can group them together, and all the users with the similar capabilities a part of the same group, and we will give the policies to the group instead of giving it to the users. However, if there are some AWS services trying to access other AWS services, in that case we have to create something called as roles. So whether it is a group user or a group or roles, all of them have to get some policies, some policies to actually get some authorities or some authorization. Without policies, they have zero authority to do anything in the AWS account. So they can't do anything without having a certain policy. Policies are typically JSON documents which are actually allowing you or denying you access to some of the AWS resources. One user can have multiple policies. One group also can have multiple policies, and one role can also have multiple policies. At the same time, in a group, I can have multiple users, but it is not mandatory for a user to be a part of that group. So user, group and roles all will be assigned some policies, and they will be able to do anything in those AWS resources depending on the conditions in the policies, and policies are typically JSON documents. Now the next one is Amazon Guard Duty. Amazon Guard Duty does the continuous monitoring of your AWS account and workload to protect you against malicious and unauthorized activities in your AWS infrastructure. It can analyze tens of billions of events across multiple AWS data sources like AWS CloudTrail, Amazon VPC flow logs, DNS logs, and we can do it within a few clicks in the AWS Management Console. Guard Duty can be enabled with no software or hardware to deploy or maintain, and straightforward push into existing event management workflow system. So you don't really need a specific hardware or software to deploy or maintain, and you can simply have an event management system and you can enable your Guard Duty, and it can start monitoring your AWS account against any malicious and unauthorized activities in your AWS infrastructure. Amazon Inspector is typically an automated security assessment service that helps us to improve the security and compliance of application deployed on AWS. The main function of Amazon Inspectors are: It can identify application security issues. It can make good use of AWS security practices, managing security compliance, enforcing security standards, and that's all what we have over the AWS Inspector or Amazon Inspector. Amazon WAF and Shield. WAF is Web Application Firewall to protect your web applications or APIs against common web exploits that may affect availability, compromise security, or consume your excessive resources in your AWS infrastructure. So this is typically a firewall for the web application which can support your web application, or I say protect your web application against the common web exploits, where AWS Shield is a managed distributed denial of services, which is typically DDoS attacks. So to prevent DDoS attacks on applications which are running on AWS infrastructure. So AWS Shield is basically protects our services to prevent us from any DDoS attacks on our application. That's all we have in this session, and look forward. Hello cloud experts. So we had some detailed session and demos on two networking services, which is like VPC and Route 53. Now we are going to talk about some other networking and content delivery services in addition to VPC and Route 53. My name is Sanjay Kumar and I'm a cloud trainer and consultant. Let's move forward. So in this case, we are talking about few services on networking and content delivery. One is VPC, which is nothing but a virtual private cloud. Route 53, which is the DNS service from Amazon. CloudFront, which is content delivery network from AWS. And Direct Connect, which is a leased line kind of service from AWS. Out of these, we had a detailed session and demo on VPC and Route 53. So now let us start with VPC. VPC, which is typically called as virtual private cloud, is a virtual private network in the cloud. So it's your own virtual private network inside the cloud infrastructure. It allows you to provision a logically isolated section of your AWS cloud where you can launch your AWS resources. So typically it gives you a logically isolated section which is virtual, and you can launch all your AWS resources within that particular VPC. It gives you complete control over your virtual networking environments. That includes your IP address range, creation of subnet, and configuration of route tables and network gateways. So what instances you want to keep it open for public or internet, or what instances you want to keep it in private, which should not be accessible from internet. You can define all these things within your VPC. We can use both IPv4 and IPv6 in our VPC for secure and easy access to resources and applications. What is Route 53? As we mentioned, Route 53 is a DNS service from AWS. DNS is a service which converts your domain name into IP addresses. So typically we have domain name like aws.amazon.com, which has to be translated into some IP addresses, and that is where DNS comes into play. And the IP addresses can be IPv4 as well as IPv6. Now, CloudFront is a CDN, which is called as Content Delivery Network, that securely delivers data, videos, applications, and APIs to customer globally with low latencies, high transfer speeds, and with a easy to deploy service. It is supported by globally distributed networks of some data centers, which are typically called as AWS Edge Location, which does cache content such as web videos, other bulky media, and more locally to consumers. So it is available more locally to consumer. It is closer to the end user, thus improving access speed and enhancing the consumer experience of downloading content and stuff like that. So it is a globally distributed network of AWS Edge Location, which is kept near to the end user so that user can have better consumer experience. It also helps in writing quickly to your S3 buckets by using an application which is called as transfer acceleration. In case of transfer acceleration, you can write your files to the content delivery network, which is CloudFront, and from content delivery network it can be quickly written into your S3 buckets. Direct Connect is a leased line connection which helps you to establish dedicated connectivity between AWS infrastructure and your on-prem data centers or some kind of co-location environments. It helps us to reduce our network cost, increase our bandwidth throughput. So instead of relying on internet, which can be a very costly affair, if you have very high amount of data to be transferred to AWS infrastructure, we can go with direct connect. And it also improves our bandwidth throughput compared to the internet connections, provide a more consistent network experience than internet based connections. That's all what we have in this session. Look forward to see you. Hello cloud experts. So machine learning is something which is getting very popular in the internet world, and AWS is no different. AWS has launched so many machine learning services, and in this section we are going to talk about some of the most popular machine learning services from AWS. My name is Sanjay Kumar and I'm a cloud trainer and consultant. So let's move forward. So in this section we are going to talk about Amazon SageMaker, Amazon Comprehend, Amazon Fraud Detector, Amazon Poly, Amazon Recognition, Amazon Textract, Amazon Transcribe, Amazon Translate, and few others. Now, Amazon SageMaker is typically helps developer to create, train, and deploy machine learning models in cloud. So typically, Amazon SageMaker helps developer to create, train, and deploy machine learning models in the cloud. Amazon Comprehend, it is an NLP service which is required to find relationship and insights in your unstructured data. Amazon Fraud Detector, it is used to create, train, and deploy mechanism for online fraud detection machine learning models in the cloud. So Fraud Detector, it is required to create, train, and deploy online fraud detection machine learning models. Amazon Poly is a service which is typically required for TTS, which is called as text-to-speech converter, which uses advanced deep learning technologies to synthesize natural sounding human speech, and it supports 60 plus voices in 30 plus languages. So text-to-speech is a advanced deep learning technology which converts our text into the speech, and the speech looks like a human speech, and it has 60 different voices in 30 plus languages. Moving on, Amazon Recognition is a machine learning service to identify objects, people, text, scenes, inappropriate content, and activities in the image and the videos. So it typically identifies various things like objects, people, text, scenes, inappropriate content, and activities in the given images and videos. Amazon Textract, it typically works like OCR, which is called as optical character reading, but it works better than OCR, and it is a machine learning service to automatically extract text and data from the scanned documents that works better than OCR. Amazon Transcribe, it typically does other way around than TTS. It converts your speech to the text. It does speech to text conversion, so it is a machine learning service which converts your speech to the text. Amazon Translate converts your text from one language to another. So these are the typical machine learning services what we have in AWS. That's all in this section. Look forward to see you in the next session. Hello cloud experts. So in the first few sections we have talked about compute services, storage services, database services, security services, networking services, as well as machine learning services. So in this section we are going to talk about some other popular and useful AWS services. My name is Sanjay Kumar and I am a cloud trainer and consultant. So what are the services we are going to discuss in this section? We are going to talk about KMS, which is the key management services, CloudTrail, CloudWatch, CloudFormation, SQS, which is called as simple queuing service, SNS, which is simple notification service, SWF, simple workflow, Kinesis, API gateway, Elastic transcoder, EMR, which is also called as Elastic MapReduce, and AWS Glue. So these are the services we are going to talk about in this section. KMS is a fully managed key management services, and it integrates with many other AWS services and helps us to create, store, and manage encryption keys. So typically this is a key management services. It helps us to create, store, and manage encryption keys which are required for encryption. CloudTrail is a service that helps in governance, compliance, operational, and risk auditing. So whenever we want to have some auditing related to governance, compliance, operational and risk auditing, then we can go with CloudTrail. CloudWatch collects all the performance and operational data in form of logs and metrics. CloudFormation used to create templates to provision, deploy and update your AWS resources in a predictable way. So what CloudFormation does, you can typically create some templates which can be used for provisioning the same infrastructure again and again, and you can do it in the predictable way. So it is helping you to provision, deploy and update your AWS resources in the efficient manner. SQS is a queuing service which used to decouple the enhanced capability of a distributed system and serverless architecture. So by using this, you can actually decouple your services from the underlying infrastructure, and it can also enable you to trigger some events for the serverless architecture. However, SNS is a messaging service which supports system to system and system to person notification. So SNS is a service which can send messages within the AWS system and from AWS system to the end users like you and me. SWF is a service which is used to build applications that coordinate work across distributed components. Kinesis is a service which is used to allow real-time processing of streaming large amount of data per second and designed for real-time applications. So real-time applications, they bring in lot of data, and that is also kind of very huge amount of data, and for those kind of services we have to use some services like called Kinesis. Kinesis also comes with multiple services which we are not discussing in this section, but it enables them to take any amount of data from several sources. Those several sources can be some IoT devices, can be some real-time applications and some web streaming platforms as well. API Gateway is a API management tool which connects the clients and backend applications and work as a reverse proxy. So typically API Gateway is API management tool which connects the client and backend applications. Elastic Transcoder, which converts, this is a media transcoding services in the cloud which is highly scalable, it is easy to use and cost effective. So you can transcode your media in any form what you need. EMR, which is called as Elastic Map Reduce, is a big data platform and it uses Hadoop, which is a open source framework. AWS Glue is a fully managed ETL service which is called as Extract, Transform and Load, that makes it easy for customers to prepare and load their data for analytics. So AWS Glue is a ETL service which is actually required to prepare and load their data for the analytics. That's all in this session. I hope you enjoyed it. Look forward to see you in the next session. Hello cloud experts. So cost is the prime motivation to move to cloud infrastructure. And how do we really manage the cost in the AWS infrastructure? Let's talk about it. My name is Sanjay Kumar and I'm a cloud trainer and consultant. Now, cost savings on cloud infrastructure. Cost saving, as we discussed, one of the major motivation to move to the cloud infrastructure. So why we want to move to cloud infrastructure? Because we want to reduce our cost. How do we really do it? We'll talk about it. AWS provide lots of tools and techniques to save your cost in long term and short term. Now, most of the services support the basic fundamental of cloud computing, which is like pay as you go. Pay as you go is the basic fundamental of cloud computing, and even AWS supports you in most of the services. AWS allows us to use most of the services for free in free tier account for experimenting with AWS. So typically, you need not to pay anything to AWS whenever you want to experiment with AWS. However, if you want to run some full-fledged workload, of course you need to pay for that. But again, those services are available pay as you go, and you only pay for the services that you use. So free tier gives you access to most of the resources which are available on AWS, and you can do all the experiments with the AWS. Now, how to save the cost on AWS? Don't pay for any ideal instance. So if you're not using any instances, either you should stop them or you should get into some kind of auto shutdown so that you don't pay for any idle instance. Enable S3 storage life cycles or intelligent tiering. as we discussed earlier, S3 have multiple tiers of storage, and it also supports you something called as lifecycle rules. So you can define lifecycle rules and delete the data which is not required in your system, or archive the data which is not frequently used. So you can do it by setting up lifecycle rules, or you can also do it automatically by using something called as intelligent tiering. Use S3 Glacier for archival. So whenever you want to archive your data, don't put it in the standard S3. You should go for Glacier for your archival files. Clean up resources which are not being used. You should always clean up the resources which are not being used for your current workloads. Choose spot instances for heavy workloads which requires low-cost computing. So whenever you want to have any workloads which are required very low-cost computing, always go for spot instances whenever you have very heavy workloads. Use reserved instances with workloads with long-term visibility. So if you have any workloads where you can commit from 1 to 3 years, you can save up to 75% of your cost on compute resources. So for that, you should go for some reserved instances. And nowadays, we also have convertible reserved instances available, which can help you to reduce your cost. At the same time, it allows you to move to some other instances with some limitations. Use CloudWatch or Trusted Advisor to monitor costs. So the best way to keep your costs under control is to monitor them, and they have tools like CloudWatch or the Trusted Advisor to monitor these costs. Use auto-scaling for scaling up and down resources whenever there are demand changes. So whenever there is a change in demand, you can scale up your resources or scale down your resources, and you only pay for the resources what you use. And you should also follow up with the consolidated billing, so you know where you are spending your money in the AWS infrastructure. And set some alerts for the billing alarms. So it is equally important. So whenever you are breaching some thresholds, you should get some kind of billing alarms which will give you an idea what is your current usage in the AWS infrastructure. Just to take an example, this is the billing dashboard for AWS. This talks about spend summary where you have spent like $7,000, and this is typically the $7,000, how it is broken down to EC2, where EC2 is having a major part of it, which is like $3,700, RDS, which is another $1,800 plus, Elastic Cache, which is some $938, DynamoDB, which is again $625, and so on, and other services are consuming some $300. So you should always have the information available on what is being spent on what particular service is being spent. So you can always see, depending on current requirements, what is month to date, what are the forecasts, what was the cost in the last month, and what is the forecast in the next month. So these are some of the information what you can get from the billing dashboard. However, we also have something called as calculator.aws, which defines your TCO, which is called as total cost of your ownership, which creates an estimate of cost for personal and business needs of AWS services. Right? By using calculator.aws, what you can do is you can create your estimate what is going to be your cost for your personal or business need for AWS services. Right? We have another application available, another service available called as Trusted Advisor, which will inspect your AWS environments and make recommendation for saving money, improving system performance and reliability, and also closing the services security gaps. Now, this is how the Trusted Advisor dashboard looks like. It talks about mainly 4 different aspects. One is cost optimization, another one is performance, another one is security, and another one is fault tolerance. So this is the Trusted Advisor, the dashboard of Trusted Advisor, which talks about cost optimization, performance, security, and fault tolerance. So it will also give you some suggestion which will make you save some money on your potential usage. AWS budget, where you can create some customized budget for your AWS infrastructure, and you can set up some alerts whenever those budgets are approaching or already exceeded from that amount which you have mentioned in your AWS budget. So it gives you basically the estimate, and you can also create some alerts whenever your budgets are being reached. That's all in this section. I hope you enjoyed it. Look for
Cloud experts. So thank you for watching this complete course, and I hope I was able to add some value to your knowledge, and I hope you enjoyed this session. So let us understand what are the concluding remarks and what is the way forward. My name is Sanjay Kumar and I'm a cloud trainer and consultant. Now, what is the summary? What are the things we discussed in this session? We started with what is the cloud computing and how it is different than the traditional IT infrastructure. Introduction and history of AWS. We talked about history of AWS, how it got started and how it evolved over a period of time. We talked about AWS console and AWS services. We also talked about IAM, which is Identity and Access Management. But at the same time, we also talked about few other services related to the security and the compliance. In compute, we talked about EC2, which is Elastic Compute Cloud. But in addition to this, we also talked about Elastic Beanstalk, AWS Lambda kind of services. We talked about storage service, which is S3, also called as simple storage service. And we talked about EBS, Elastic Block Storage, EFS, Elastic File Storage, and Amazon Glacier. We talked about RDS, Relational Database Services. In addition to this, we talked about DynamoDB and Redshift kind of services in AWS. VPC, which is Virtual Private Cloud, and Route53, we discussed on the networking and content delivery. And we also talked about CloudFront and some other services in the networking and content delivery domain. In machine learning, we talked about few services related to Amazon machine learning services. And finally, we concluded our session with our cost management services available on AWS. I hope you enjoyed this learning, and if you have any feedback, please provide your feedback in our video comment section. What is the way forward? The way forward, if you want to learn more about AWS, the only key is to practice, practice, and practice. So you have more you practice, more you learn AWS. If I will be coming up with more and more videos, and if you want to be notified for those videos, please subscribe to my YouTube channel. If you have not already signed up for AWS free tier account, please go ahead and sign up for AWS free tier account and start exploring it. However, before you do this, please make sure to understand that free tier limitation before you start using it. So before you start using it, please understand what are the free tier limitation, because if you don't know this clearly, you may incur some of the cost on your AWS account. If you want to take some certification exams, this course may not be sufficient for cloud for a solution architecting exam or some other exams which are available on AWS. However, I will add many more sessions in this, and we will move closer to the AWS certifications with some more sessions on some particular topics. And last but not the least, if you don't understand anything, do not panic. Nobody knows all the services of AWS, and it is not mandatory for everyone to be an expert in AWS. However, if you really did not understand any services which I mentioned, please feel free to go back to those videos and watch those videos again. And if you have any other questions, please feel those things in my comments, and I will be more than happy to answer your question. If you really want to learn AWS more, please send me your feedback, and I will be coming up with more videos based on your interest. That's all in this course we have. I hope you enjoyed the course and able to learn few new things. My name is Sanjay Kumar, and I'm a cloud trainer consultant. Look forward to see your feedback and your comments on this particular course. Thank you very much.